I do have it here. Sorry.
Oh, okay. I was just walked everywhere looking for it.
Sorry.
It's a new sheet if you want.
Okay, thank you. And then I'm assuming this is the settings. 320 ISO.
Yeah. But you can change that if it doesn't end up looking right today, because it might not.
Yeah.
Huh?
I would keep that ISO though.
No.
This is already at
I don't have much
125.
leash and I'm just trying
It's
to
so
stay
bright.
out, so.
You might want to put the exposure of 1 when it gets to 80. I don't know. Just you can make a call on like whether it looks like we can see enough, but like you don't want things to get like so bright that you can't tell what they are.
Yeah. Okay, so we'll probably have to change them between the first and then later ones.
Probably.
And that's okay.
Yeah.
Alright.
It's changed every time, so.
Yeah, sure.
Okay, what would you like now, Sean?
Can we do a zoom on the better to see
Sure.
the
You guys be okay with me taking a couple of super close-ups? Is that okay? Just went by do some of the zooming. Is that right?
It's all you.
Yeah, so-
You good, right, Doug?
Yeah.
Yep.
Yeah, I think it's great.
Behave. That is brutal. Yeah. See which way it burns, right? Yeah.
Good morning, everybody. Welcome back to the Divestream. This is a live view of ROV Sebastian. It's about 8 in the morning on RV Falcor 2, research vessel Falcor 2. And we're very excited for you all to be joining us for dive 899, almost at 900. And right now we are doing a little filming for our artist at sea, Paula. We are releasing a really beautiful feather, and I'm hoping she'll be able to come on in a minute and explain what she was doing and what her aims are, but just getting the camera settings focused for that.
There's like no current. Yeah.
Yeah, we've got Doug and Andy on pilot controls. We've got Alex as well on camera controls at the moment.
Yep. Thrust ahead. How long would you need for your shots?
How is any particular length you use? Just need a few seconds.
yeah, I would like to see if you can
Yeah.
And as always, let us know if you have any questions. We are monitoring the chat on YouTube and Twitch.
Do whatever you need to do.
that looks
Really beautiful shot, wow.
because I'm gonna get some shots with a microscope too, so
Yeah, yeah.
much.
Thrust ahead.
Yeah, that looks nice.
Yeah, go ahead.
Buenos días a todos. Bienvenidos a nuestro nuevo inmersión. Estamos en el alta mar a frente de Brasil. Lo siento por mi español, pero yo puedo explicar un poquito que no vemos.
I think it's good, yeah.
Es un pluma de rea. Qué hermosa pluma, ¿cierto? Y esta pluma es por una instalación de nuestro artista a bordo, Paula. Y ella puede explicar un poquito más en unos momentos.
I think it's nice when it comes from the corner
Yeah.
up.
Yeah.
No, no es un nidario.
It is always moving.
Yeah, the
from
opposite
side to
direction, yeah,
side.
exactly. So that's to not touch the camera on this. Try and get a shot at the end of it and then we'll just leave it.
Yeah, that is really nice.
This thing keeps flicking from on.
Okay,
Mm-hmm.
I gotta fly.
Sí, exactamente, es una presentación artística.
It's just in auto now. Now it's out of auto, yeah.
So it's manual right now.
Yeah.
It's in auto now.
Right.
How's that?
So on your knee.
I can actually just get up if you want.
So the current should be flowing across the pelvis.
Okay. Are you happy with the camera?
Yeah.
When do you want to let go?
Just wait a little seconds and then.
Push that button right there.
Do you want me to?
Yeah, push it right there. Just hold it down.
This one?
Yep. Hold it down and it'll open. When you're ready. Okay. You're welcome.
The glasses will open.
Yeah. Happy?
Yeah.
Good. Well done, guys.
I'm frozen. All right, Andy. Whatever their program is.
Happy? You want me to turn off all the extra recordings?
Sorry?
You want me to turn off all the extra recordings?
Yeah, I think
Okay.
we have enough.
Okay.
What
Sounds
are
good.
the people saying?
They're saying it's beautiful. Did you want to explain a little bit what you're doing?
Sure.
Here. Sit here if you like.
Yep.
You get to sit in
She wants to start at
the
125.
special seat. Yeah. Upstairs. Thank you.
Hola a todas, a todos. Mi nombre es Paula Proaño Mesías y acabaron de presenciar la tercera iteración de mi performance que trabajé en esta expedición. Yo soy la artista en residencia de la expedición.
From our previous transects,
What you got?
we probably got adjusted, but we had 320 for the ISO.
La acción
And it says
hace referencia a los rituales de agradecimiento y de ofrenda que se realizan en la comunidad lafkenche. Lafkenche en español significa gente del mar
What lights did you
y es parte de la comunidad mapuche.
have? Coming on.
Me interesó investigar un poco más sobre sus prácticas, ya que la expedición salió de los territorios que ancestralmente les pertenecía a la comunidad mapuche, en lo que ahora se conoce como Chile y Argentina. Así que esta ofrenda lo que busca es hacer una inversión de lo que normalmente hace el Rob Sebastian, que es extraer muestras y subvertirlo hacia una ofrenda como una acción opuesta y de agradecimiento también al mar por todo el sustento que nos da y por todos los procesos que muchas veces son invisibles pero que forman parte muy importante del sistema que todos somos parte.
Okay.
things to go off of, but not much.
I'll switch it on in this position. All right, that's about midpoint focus there.
I think this looks good. Yeah, we can use this.
Okay. So we're going forward for 15 minutes. Is that what we're doing?
Yes. You said there's like pretty much no current here.
Pretty much.
Okay, so I guess about 0.3 knots is what we were shooting for.
Are you wanting to go south? Or
Yeah, south pushes us into the.
Okay. All right.
Okay.
South.
Now we were gonna push back.
So. All right. I'll have the vessel start moving.
Right.
Bridge ROV. Bridge ROV.
ROV bridge?
Yeah, Raphael, we're gonna start heading south. Can you start heading south at 0.3 knots, please?
Yeah, no problem. Start heading south at 0.3 knots.
Thank you. Top side of the ROV.
ROV, please.
Vessel on the move.
Thank you.
Thank you.
Yeah, that looks good. Okay, I'm gonna start the transect.
Bridge ROV.
Yeah, go ahead.
Can we bump the speed to 0.5 knots, please?
No problem. Bumping up to 0.5 knots.
Thank you. I'm just having to move south, so you know.
be able to see much if you turn out all the lights at this depth.
Well, I think we'd. Oh, you mean like from surface?
Yeah. I mean, there is light down there.
I mean, probably. It looks like you can already see a gradient from like top to bottom, I feel like. It's amazing how much less particles are in the water.
Have we started the survey?
Yeah.
Oh, okay. I didn't even realize we'd started because it looked like there's nothing in the water. I mean, I can see it on that screen.
Yeah.
Yeah.
I've seen a few things coming by.
Yeah.
Oh, there's something.
Particles are a lot smaller.
Yeah.
And on this screen, I can't see them hard. I mean,
There's been some of these. I'm curious what those things are that have been going by. If they're like maybe like pyrosomes, but I can't tell. That was a big siphonophore. So for the audience watching, what we're doing here is what we call a transect. So it's like a kind of standardized quantitative survey of everything that's in the water at this depth. So right now we're at 125 meters. We're gonna do this a number of times, getting deeper and deeper. And so we're at like a consistent speed and with like sort of the same camera settings so that we'll be able to go back later and look at this footage and quantify
Fred, your RV.
everything we're seeing.
Your speed is 0.6 knots.
Copy, bumping up the speed to 0.6.
So it's not like as exciting maybe to watch because we're not like stopping and zooming in on things, but it's really valuable for us because we're quantifying what is there. And then on the way up, we'll like stop and zoom on stuff. And yeah, where we are is we've gone quite a bit north from the last ROV dive that we did, and we're now in the tropics. And so the water is a lot clearer. So down 125 meters, we can actually, still see some sunlight, which we didn't really at our last location. So that's why it's this really nice blue color. Nitro, where was the DCM here?
150 meters.
Wow.
Yeah.
What was it at the last one? Like,
I mean, the last one was like 110.
Oh, okay.
Before that was like 30.
yeah.
Yeah. The light penetrates very deep here.
Mm-hmm. it's the end of the transect. Our next step is going to be 250.
Okay. 250. Okay.
Are you gonna keep this heading the whole time?
Can do, yeah.
Keep going due south.
Yeah. I mean, I can change it. Can we come off?
Good, Roby.
Yeah, Robert, really good.
Yeah, can you come to a slow stop here while we go down to the next step, please?
Sure, no problem.
Thank you. Thank you.
Then we just come around and go much further.
Yeah, that's good.
Problem. Where are we going again?
250.
250.
Is this the lighting that,
So it looked okay up higher, but I think I'm gonna have them make it brighter.
increase? Yeah,
Do you think I
it's a
should
little
do
too dark.
the ISO or the iris?
I would do the iris.
Okay.
Yeah, because
Because this is, it said
we
just
talked about
2 clicks up from it closed, and that's still pretty dark.
That's 2 more clicks.
Yeah, I think something was. Yeah, I think this is too dark.
Yeah.
Yeah.
Okay. I think it was okay for the first one, but definitely not for this depth.
Okay. Yeah.
How's that?
That's better.
Yeah. I think that's probably good. So
Yeah.
what was that change?
At least 6.
Okay. Just so, but that you just changed the iris.
Yeah.
Okay.
But the ISO is at 500 as well. I
Okay.
can decrease that to 320 if you want.
No, I think this is good.
Okay.
Wait, what's the ISO at?
500.
Oh, okay, interesting. Because yeah, we had it before. We had it at 3.
But back on this, whatever this one was, it was at 640.
Yeah, that was too high. That was way too high.
Okay. So it was at 320.
That was
This is
better.
500?
So the discussion we had was that it's better to.
That's 320.
Now I might mix this up. We were trying to get a deeper focal distance
So for that, you want to keep the iris closed as
More
much as
closed.
possible.
and increase the ISO.
Yes.
But then
I
there's,
think.
there's something where we don't want to increase the ISO past a certain amount because then it'll not look that great.
I think that's when you get noise, maybe.
Yeah, so I think.
So I think it's good to do a little bit of each, maybe. So like what he did,
This
where
is 500, and that was open.
Okay.
6 mix.
Yeah, I think also just because there's not much in the water here, it kind of just needs more light, right?
I think this looks
All
good.
I can give it, so all I can do is open the iris or the ISO.
Yeah. I think this looks
Yeah,
good.
that's what I meant. Yeah. But is that your experience too? Just like when you dive in places like this, you kind of need more light to see stuff, or is that not? Does that not make any sense?
Typically, we just, whenever we're transiting, we'll just leave the ISO in auto, and then when we find something that we want to go see, we'll adjust them.
Yeah, we just need to keep it stick like this thing.
I think we should stick with this.
Okay. If you start seeing animals that are all blown out, then
You can, yeah. It's just hard when there's so many animals.
Yeah.
I mean, we did see a number of jellies in the first one.
okay.
There was like, I don't really know. They might have been like pyrosomes or something, but they were like kind of long, gelatinous tubes. I don't know. It's hard to tell.
All right.
Thanks. I was gonna be like, oh, I need to adjust it, but what do you want?
Yeah.
Okay.
So that's a 250.
Okay.
Let me know when you start moving forward. This will start going.
You ready?
Yeah, I'm ready.
Bridge ROV?
Hello, bridge.
Yeah, Raphael, can we start that move at 0.6 at 180 again, please?
No problem, I'm recommencing the north south 0.6.
Thank you.
Okay.
Oh, yeah.
No, thank you.
We have a question about how long we do each of these transects. So at each depth we stay for 15 minutes. If you're up for chatting.
Yeah, no, we are not. I'm not doing anything like that.
Okay, cool. You could, give you a mic. Seems like mostly Spanish speakers, but I don't know.
Okay. I have Paula here next to me. We're
Yeah,
to help me.
if you want. I know you talked a little bit
don't know
earlier.
much about this, like of the actual, species.
Mhm.
Everything that happens is something that you want. But you speak Spanish too.
Yeah, a little bit, yes.
Just up to you, whatever you want to talk about
Are
or
there-
answer questions. Is the chat like automatically translating for us?
Yeah, so it's not perfect. Do you want me to switch it back?
Yeah, I think.
Yeah.
Ahora le están preguntando sobre cuál es la razón de la pluma. Sí. Can you get the microphone on?
Yeah.
Hola, ¿qué tal? Acá Paula, de nuevo, la artista a bordo. Para los que están preguntando sobre la performance y la razón de la pluma, bueno, como les contaba, esta performance hace eco de las prácticas espirituales que la comunidad lafkenche practica en relación al mar y a la divinidad que ésta representa, y ellos usualmente utilizan plumas de ñandú o choique. Choique sería como la traducción de ñandú a su lengua, y utilizan este tipo de pluma porque para ellos en principio los pájaros significan como un vínculo con lo divino, con el plano espiritual, y también porque el ñandú es una especie endémica de ahí y está muy presente en sus vestiduras. Ellos siempre la tienen ahí muy presente cuando van a hacer ceremonias, e incluso hay una danza especial que se llama la danza del choique, en la que ellos tratan de emular los movimientos de esta ave. Así que un poco como haciendo referencia a este tipo de prácticas, me interesa utilizar este material o esta pluma como para hacer eco de lo que ellos hacen.
Qué bonito. Creo que es algo que es legal mencionar también, es que estamos solo viendo partículas acá, de vez en cuando vemos algunos animales, pero para algunos estas partículas parecen insignificantes, pero para nosotros acá en nuestra investigación esto es lo que estamos procurando, la nieve marina, es porque justamente estas son partículas y sedimentos que pueden tener materias orgánicas y queremos colectar esto para investigar lo que tienen en esto. Si tienen material orgánico, las bacterias, los microorganismos, si tienen virus y justamente entender más sobre esas partículas pequeñas para entender cómo ellas ayudan a moldar los ciclos del carbono oceánico. Esto es algo que es muy interesante, por eso que me encanta mucho ver este microuniverso marino cuando estamos haciendo el ROV. Tomas aquí. Respondiendo a una de las preguntas del chat, la pantalla sonar, ok, ya está nos mostrando, ahora estamos haciendo con nuestro ROV, que es una especie de un submarino que ponemos en el fondo del mar, su nombre es Sebastián. Estamos haciendo un mergullo a procura de animales, también de muestras de specimens que estamos haciendo ahora. Entonces lo que vemos en la pantalla es solo las partículas marinas, los restos de animales, de rejectos que tienen en el mar. Y creo que es esto que principalmente estamos viendo ahora, no tiene ningún animal. Cuando aparecer va a ser bien claro, nosotros nos empolgamos bastante, que muchas veces intentamos capturar los animales para estudiarlos, para colocarlos en museos. Pero ahora solo lo que estamos viendo es la nieve marina, que son partículas como las feces y otros partículas que pueden ser tanto de animales cuanto de otras formas de vida que tienen en el mar profundo. Entonces es esto que estamos viendo ahora y es esto.
Probably pretty good.
Can I get you to slow to a stop or the next step, please?
Probably that. We'll go with that.
The next one is 375.
375. Happy with the lighting and everything.
Yeah, we're gonna stick this one.
Thank you.
It is. No, it is really good.
I speak a little.
Hola, buenos días a todos. Soy Thomas, soy uno de los cientistas que está en el equipo del Bioreactors. Estamos ahora en el medio del mar Atlántico, de lo South Atlantic Geyser. Estamos ahora hasta 342 metros de profundidad. Estamos haciendo nuestro ROV. Estamos a procura de algunos animales, de descubrir un poco más sobre la nieve marina y que tiene sus rejetos, microorganismos y cómo esto se contribuye para los ciclos del carbono oceánico. Saludos a todos que están acá de Latinoamérica. Soy Tomás, soy brasileño, entonces ya les pido perdón por mi español si está un poco oxidado. Pero si tienen alguna pregunta, pueden preguntar. Estoy más que dispuesto, yo y todo el team que tenemos acá para responderlas sobre nuestra investigación, cómo llegamos aquí. Tenemos Paula también, la artista, que está haciendo un manifiesto que ya se ha explicado hasta poco, pero si tienen más preguntas, solo mandar en el chat. Muchas gracias. Oi, aqui respondendo uma pergunta agora em português. Então, eu faço parte do departamento de fisiologia no laboratório de metabolismo e reprodução de organismos aquáticos da Universidade de São Paulo, na USP. Mas eu estou aqui por causa de uma bolsa de estudos chamada Rise for the World, que é parte de um programa do Rhodes Trust com o Schmidt Futures, que são duas organizações, uma delas a Universidade de Oxford, uma delas é um fundo filantrópico, que eles fazem um programa que eles chamam cerca de 100 adolescentes e jovens do mundo todo por ano para receber essa bolsa, e eles ajudam a pagar os custos de educação e com diversas outras formas de apoiar o aluno. E aí eu tô através dessa organização aqui, só que eu também consegui chamar o meu laboratório para fazer trabalho aqui sobre reciclagem do carbono oceânico e impacto fisiológico, questão de microplástico, assim. Trabalho bem legal aqui. Oi, eu me chamo Thomas, eu sou estudante da Universidade de São Paulo e Fellow da RISE de 2023.
We can also answer questions on the stream in English, just because a lot of our audience, especially at this time of day, is from South and Central America. We have Thomas answering questions in English and Portuguese, but in Spanish and Portuguese, but I can answer questions in English as well. My name is Nate Miller. I'm a postdoc from the Monterey Bay Aquarium Research Institute. On this cruise, I'm mostly studying the marine snow that you can see, all the little particles all over the screen. I'm interested in the microbial communities that are associated with it.
para as pessoas do Brasil aqui, just a second, I'm going to speak a little bit in Portuguese to answer some questions for the Brazilian people. Mas basicamente o projeto que a gente está fazendo se chama Bioreactors, né? O papel do intestino, né, e do gut, como a gente fala no inglês, dos animais na ciclagem de carbono do oceano. Então, basicamente, o que eles estão estudando é entendendo sobre como a microbiota intestinal, do esôfago, está correlacionada com a ciclagem de carbono no oceano. Seja essa por fazer correlações com as partículas que tem no oceano e fazendo comparação dos micro-organismos que tem nas partículas de cocô do oceano com os que a gente encontra dentro do trato gastrointestinal dos animais, junto com a gente fazendo outros trabalhos em relação a entender sobre como essa alteração muda nos ciclos migratórios de animais. Então, a pesquisa que a gente está fazendo é para entender bastante sobre como migrações como uma migração vertical chamada diel vertical migration, em que animais durante o dia eles sobem porque tem maior disponibilidade de alimento perto da superfície, eles comem bastante e aí eles descem, né, de volta para os mares profundos, e nessa migração eles acabam levando muito carbono, assim, em forma orgânica, nos alimentos que eles processam, e aí eles acabam deixando no fundo do mar. E essa é uma forma muito forte que, né, que tem uma influência no clima global de como acontece o armazenamento do carbono no oceano. E aí justamente entender como que o microbioma dos diferentes animais, ou seja, esses animais crustáceos, peixes, salpas, águas-vivas, como que a microbiota dos animais influencia no ciclo do carbono, porque micro-organismos, não só o fitoplâncton, né, que ele é capturado na cadeia ecológica, assim, e vai sendo passado de animal para animal, mas os micro-organismos que habitam esses animais e estão presentes no mar profundo conseguem transformar o carbono. E aí, justamente, entender um pouco mais sobre isso é o objetivo da nossa pesquisa.
There's definitely a lot more stuff at the steps than there was closer to the surface. I think around 500 meters is where we're gonna see the most, like, fish and stuff, probably. That's the end of that transect.
SO2 stop, please.
Okay, cool.
Thank you.
Yeah.
100.
Yeah. So our light settings might look a little different from like what you might be used to. We have them at a very specific setting that we keep consistent, because what we're doing right now is video transects, where we're getting a quantitative measurement, a video of like all of the different organisms that are at these depths. So yeah, we have the lights set basically to maximize like how far we're able to see, but also how much stuff is able to be in focus. So when we go back later and analyze the videos, we'll be able to see the most amount of stuff. So when we come back up, when we're like zooming on things, the lighting will change, but for now we're going to keep it at these settings. was like, I think I know what that says. So someone's noticing that there's a lot less marine snow that we're seeing right now compared to some of the previous dives. That doesn't really have anything to do with the lighting that we have. That's actually just that there is less marine snow here, less particles in the water, and that's because as we've gone north on this expedition, we're going to a part of the ocean that is what we would call less productive. So there's less phytoplankton in the surface waters, and because the phytoplankton sustain everything in the ecosystem, when there's less of that, there's less of everything else. So there's still a lot of like diversity in terms of the plankton and like the fishes around here, but the biomass, just how much of it there is a lot less. So we're still gonna find some cool stuff. It's just more spread out.
We're at 500.
Okay.
Bridge ROV, can we resume the move south at 0.6 knots, please?
Copy, resuming south 16.
Thank you.
Okay, starting transect.
happy you're here. Always good to see you.
What do you mean? Is that our ways? Better than last time. This one, I guess. Here? Get my flying hours.
So we can just keep it SOI. 6 knots, 2 south.
Cruise.
When we get ready to change our depth, so we stop.
Trim it down.
Keep going.
And just stopping every time we're coming down. Yeah, just hit the station.
The alcoholers on then. The alcoholers are on. Because we're at 500 meters now. Just to make sure that's
Um, 7.5 minutes.
You seen some cool stuff so far?
At this step, the most so far.
Oh yeah?
Yeah. It seems like there's a lot of cool jellies that we'll be able to look at on the way up.
You've seen some good stuff?
I mean, as much as you can see it in the transect.
Yeah.
Yeah, it looked like there was like a big ctenophore that went by
Uh-huh.
that, of course, we couldn't look at.
Yeah. Cool.
Demetra, can you take over for just a minute? Yeah. Peace out.
Sure.
This is why the minutes so that I'm just kidding.
Ooh, look at that. Coming right at us. Oh, there's something cool.
Are we going down the same depth as before?
Yes, we are. Takes a long time.
Yeah.
Sorry about that.
Oh, it's alright for us. We'll be here until 12 o'clock.
Doing the survey.
Maybe this guy.
Just had too much coffee.
Yeah, breaks. If you want a break, I can come in and hang out for a while.
I'm fine.
Go see what came
Maybe
up in the net.
just so I can have lunch when that happens.
Oh, okay.
But
We're
I'm
still
good.
thinking about another dive later today. Is it tomorrow? or-
Tomorrow, a day after tomorrow. It'll be a night dive.
Oh yeah. So, yeah, what, going in at like 6 or 7 or something, or going in at midnight or what?
I don't remember. We don't have a daily plan. I remember that. It's not on the daily plan yet.
No.
I need to get my computer. Do you want to know? I think it was going in
Well, before Doug goes off.
Yeah. I know. It's fine.
Duty.
I just didn't see it on the plan, but the guys had spoke about it.
Yeah, there should be one more at night.
That's happening.
And tonight, it's not tonight, and tomorrow night we're mock messing, so it might be the following night.
Oh, okay. Is this still at the same station?
Yeah.
It's the one we're staying at for a while.
Yeah.
Is this the last long one, or is there another
Yes,
long
and
one?
this is it. Oh my god, that's
that was
amazing.
That was a big one.
Shoot.
No, we've seen a lot of those.
Well, this one's footage of one.
We'll see more, I think.
So that was we're at 500, so maybe
Yeah,
if we go back
no,
to-
but we've been seeing those throughout.
Oh, you have? Okay.
Yeah, so I think we'll see more. Don't worry. And I think it'd be cool to collect them.
It would be cool.
Since we
Just say the word if you ever want to stop the transit.
no, no. If we do that, we have to
Not
start
stop.
over. You know,
Oh
right?
my god, that will be your punishment if you stop.
If you stop, you have to start from the beginning.
Start over again. Just at
stop
this
and then
depth.
also have a cute little zoom with the camera.
Sit, I'm ready.
Between
Like,
depths,
it
you can
comes.
take a minute if something really cool goes by, right? During when
Yeah.
you descend.
Oh, yeah.
Aye, if we're descending through,
Yeah,
if
sure,
we
definitely.
will happen to
If something crazy happens.
cross something.
Whoa! Right at the camera.
That's good. Right, we might see something on the way down. If we do see something, I'll stop, and you can decide. We'll just carry on.
Yeah. We just can't really collect anything because then if we take it down and back up, it's like.
Yeah.
So Alex was looking for some footage of that exact
Okay.
thing because he has some of one that's kind of folded up.
Okay. So that's what
Oh
it's
yes,
disturbed and
I know what he's
folded
talking
up.
about. I think
Yeah.
those are forums actually.
Are they?
I'm pretty
I was
sure.
wondering if they were forums.
Yeah.
Okay.
Okay, so noted. If we see one of them, we'll stop.
Yeah, but if it's a forum, he doesn't want it.
Oh wow. Okay.
So picky.
If it's anything with silica, he would want it.
Yeah, because I was thinking it's like they kind of.
I know.
I
but
think
it
they've been looking
doesn't-
more like
yeah,
that.
I know. The center was so small though that I was sort of like it didn't seem so
Yeah.
forum-like to me, but maybe
I mean,
it is.
yeah. I could
Yeah.
see it being either way, but
I
I've
know,
been
I
I've been calling them forums, but I don't
Okay.
know if that's
All
true.
right. Well, they might be forums. That's what. Yeah.
I think it'd be cool to collect one if
It was
we
tagged as
could.
radiolaria by the
Ah.
annotators.
Yeah.
That's why I'm saying radiolaria. But I agree with you. It could be a forum.
Mm-hmm. Because that one Theodarian we collected before was really cool. I got it was so bioluminescent. I got some photos.
Cool.
One time during a video transect, me and Juliana made Sunny stop in the middle of the video transect because we saw an onyx squid with eggs, and we're like, "You're not letting that go."
There's some things that you just have to. That was cool. I think all the eggs.
Yeah.
That was
Yeah.
cool.
Anitra.
What?
This is so
Oh.
it was like so it kind of fell apart. So like this was the main part of it, but then I had a couple of extras.
Mm-hmm.
But you can see that the little bits were glowing.
Mm-hmm.
And it has like this really distinctive pattern where it's like multiple little
So
things.
that's what I couldn't understand if those little things are cells attached or if it's part of the same organism because it's a single cell, but it looks like it's. got
So
these
I guess
other
it's
things
actually
attached.
not a single cell. I think
Right.
each one of these is like one or two cells.
But I think,
But these little dark things are like the phaeodia, which is like the little packets of organic material that are, I think they're waste or before it's consumed. I don't know.
okay.
Colleen knows more than I do.
cell is inside though.
Yeah, so the cell is like, there's like two cells like here on each one of these things. There's apparently like two of them. And then there's nothing really in the middle of this big
Okay.
cage.
Okay.
Oh, okay. That's the end of the transect.
Nice.
I love how every dive we have a different arms.
I wondered what that one was. It was what's okay.
Well, I had a really alarming one before, so I tried to change it to something a little more soothing.
More radio friendly.
It is like right next to the microphone.
Bridge ROV.
Yeah, go ahead.
Yeah, we can come and all stop there. We're ready to descend out to the next zone.
Copy, coming close.
Is Is this the screen that's 4K?
Yeah.
And this one is just HD?
They're both 4K.
Both are?
Yeah.
Oh, okay.
The monitors are a little bit different. This
Okay.
monitor's a bit more clearer than this one.
Okay.
Yeah, they're both 4K cameras.
For some reason, Alex didn't seem to.
And the position related to the light makes.
Mm.
We don't record we don't record
So the next
the
step is
situation.
625. 625. I should set my phone to the duck quacks like Anitra does.
Yes, we
Should get-
equip it. We just clipped it before we held it for like racing into it.
Do you have the settings
What were you
with your
saying?
cameras recorded for your
Yeah.
transect? You know what
Yeah.
is. So if I end up having to change it, if we do see someone on the way down and I change
Yeah.
the settings, you
We
know
can go
we
back.
can change them back.
Mhm. I was just saying I should get the duck quacks like you have.
Oh, yes. But your name doesn't mean duck in Italian.
Wait, is that what your name is?
Yes.
That's so funny. Is that a typical Italian name?
If you're in a restaurant ordering Nitra alla Orange. Yes.
That's
No, when
great.
I meet Italian people, occasionally they will just burst out laughing.
Oh.
What? Your name is what? Yeah. It's true. I actually didn't really know that until I was much older. Like, not when I was a kid, I didn't realize my name meant Italian.
Is it a Spanish name?
Italian. No, I mean my name
Yeah.
I was named after a boat.
Oh. That's
But
apt.
what are the names?
Yeah.
What?
What are the names? Anitra?
Anitra, yeah. Was the name of my parents were sailing for like a year around the time I was born, and so they stopped. My mother was pregnant, and she was like swinging the hammock on the sailboat and looked at the other boats in the harbor, and one of them was named Anitra, and she gave me that name.
Hmm.
It's a good story.
It's a character in a Ibsen
Yeah.
play called Peer Gynt.
Mm.
Well, my name was the most popular name in 1987. So my mum wasn't very original.
It's the year I graduated high school.
Are you the only Anitra you know?
You know, there are a couple of others. Once when I was a kid, my mother was yelling after me because I was running off on the street in New York, and she was yelling my name, and this woman who must have been like 99 years old stopped and said, "Is your name Anitra? I've never met another Anitra."
No way.
She was so excited. And also, I think the woman who she's not the one who turned the letters on Wheel of Fortune, but she was like, maybe it was one of the game shows on TV. The woman who was like the like hostess is named Anitra. She's an
So
actress.
there's only two nowadays.
But there's a pretty famous drag queen named Anitra.
Really?
It's spelled with an
Oh, okay. Sometimes
That's the only other
sometimes
time
the
I've heard.
Italians spell it that way for duck. Yeah,
I don't know why she's named that.
interesting. You know, there's a few of us out there.
In Portuguese, there is kind of similar. Is the Anitra? Is Anita?
Yeah, we have Anita
Yeah.
too. Yeah, people. Yeah,
Mm-hmm.
I often get called that. I get called many things. So you're at 5. Yeah, so 500 is
Yeah.
a lot of animals down at around
Mhm.
500. 5.
And also, it looks like there's another kind of separate band,
Yeah.
a little bit deeper.
Yeah. Like right around where we are, we're seeing a lot of crustaceans swimming around. That's why I was
Mhm.
wondering if you can see them in the acoustics, and you can.
Mm-hmm.
That's cool. It's kind of amazing. You really can tell here in the end layer.
Yeah. I think because we're not coming up until 6, right? So we'll probably see the migration a bit on the way up. Unfortunately.
Yeah. I mean, we could come up whenever. Come up earlier. I just put that on because there's nothing else that
Mhm.
needed to be done, so we may as well spend the time looking around. We have yet to fill all 6 jelly jars or use the vacuum.
No, they used the vacuum at all.
Alex just showed me footage of you guys capturing it was like this cluster of
There's one of these things, is it?
radiolaria.
Oh yeah, let's.
Yeah.
Want to look at it?
Yeah.
Yeah, get some good footage of that.
Leo, do you want to mess about with? How do you mess about with lights?
What camera do you
Nice.
Do the-
Oh, nice. So that's a 4M, you think?
I think, but I don't know.
It's so hard to tell, isn't it?
Yeah.
No. Yeah, and I'll come ahead a little bit.
It almost seems too shiny for calcium carbonate, but
I know, that's what I was like, wow, that's some very delicate calcium carbonate.
but one of the other ones I saw, it looked like more irregular in the middle. You can kind of see on this too, which made me think 4M, you know?
It looks right, it's blow bait or something like
Yeah,
that.
where it's got like, exactly, it's got like a few
Something.
different
Oh, wow, nice.
things stuck together in the
Nice.
center,
That was good, that was a good focus.
I'll try and get a
you
little
know?
bit.
Yeah, if you do, it's probably gonna see,
Yeah.
it's already feeling your presence.
They're so delicate.
These things just do not live in an environment with any turbulence.
Mm-mm.
So incredible.
Let me know
Wow.
if I can zoom like
Do a little bit of zoom, not too tight.
okay.
Struggling a little bit with it.
Yeah.
Yeah, it's good. Good reception.
Maybe on the way up we can try to collect some,
Yeah.
and then we
Yeah.
can be a little more confident about what it is,
Yeah.
because they seem pretty common. I'm sure we'll see more.
But you can flick the autofocus a little bit. Cycle the autofocus,
Yeah,
touching it
I
all.
am.
Okay, thanks.
Well, that was pretty cool.
Okay. It's still
Okay.
there, but I mean, we can
We can keep going.
leave it.
Yeah, it's all tangled up now.
It's getting all
Mhm.
Yeah.
sticky to itself. I wonder if they can unfold from that or not.
That's a good question. Well, because they must bring them in order to get the stuff
To
off of them,
feed.
right?
I mean,
Unless they just have that in order to be more buoyant.
I don't know.
I don't know either. I'm just saying
I also
things.
wonder if they'll show up in the acoustics. Are they too
Probably
small?
not.
They're too small. Right?
Well, and they don't have any sort of like
Yeah.
gas bladder.
Right.
500.
Where's the ice again?
500.
Yeah.
Didn't mess about with it. Did you move the iris? I didn't move the iris.
Iris, it says it was like 6 clicks from the like.
Did you touch
from
the
most
iris? I
closed.
didn't touch it. I did. Okay. So what was it, sorry?
So from closed, it would be 6 clicks up. 500.
But we've still not got all the lights on here.
Oh, yeah. I was like, that doesn't look right.
Yeah.
Oh.
This still looks a little dark.
Yeah.
Yeah, that's the same lighting that was on.
Huh.
It looks pretty similar. I thought it was quite dark
It's
looking.
darker, yeah. I mean, we were also shallower.
Yeah, that's true.
Yeah. So I guess maybe we can,
Do you want to open up the diars?
I guess a little bit more, yeah. That looks good to me.
Yeah. Okay, pretty much there.
And you have like autofocus off and all that.
Yeah, autofocus is off. Do you want to see where it's focusing, or are you happy with like how it looks like that? It's just focused
Looks good. Yeah, I mean, we
That's something.
basically said like midpoint,
midpoint.
mid-range.
pretty much.
Yeah, then that's
Yeah.
good.
And then how's that speed for you?
Let's go a little faster. We were doing about 0.3 knots.
0.3. Still saying 0.2, but
It looks pretty good. I mean, basically
that?
0.2 to 0.4, anywhere in there. That looks pretty good to me. So, yeah. Okay, I'll start the transect.
okay, Bridge, we can start that move again.
Go ahead.
Okay, so this is interesting. I just searched the image of that thing, and AI says it's
AI doesn't know anything.
well. I mean, it might lead me to something that knows something.
That's true.
Finding images that are similar.
A radiolarian?
that we were just zooming in
We're
on.
trying to decide if it's a radiolarian or a
Like,
form.
are
Do
you
think
sure
it's
it's a radiolarian?
I'm pretty sure it's a radiolarian.
okay?
I mean,
We've seen those before.
Mm-hmm.
they're saying it's a
There's
well,
one right there?
AI is calling it a in quotes
That's
flat
also
nose.
true.
I don't know what that means.
AI doesn't know.
I know. They misidentified a couple of things that we've had. But I just thought I might find other images of it. I was just doing an image search, not an AI search. per
Oh,
se.
yeah.
It's so interesting. I searched that image and it just is talking about fireworks. It's a firework.
Yeah.
It's really interesting. like it's a protist, and that will help.
Yeah. There's a lot of shrimp at this depth.
I mean, I should send it to his angel. She can probably know what it is.
Mm-hmm.
But this site is saying. Okay, so the NOAA, somebody posted an image that looks exactly like ours on the internet, and they said that NOAA says our scientists team believes this is a foreign mammifera, but for a while we were unable to identify this strange looking sunburst organism.
Look up this.
Oh, you have a name for it?
Maybe.
This thing.
Definitely under this area, but
I mean, people are like, have similar images, are like, what is this? It's kind of interesting. Actually, the species name and everything. Those images don't look like what you're seeing to me at all.
this is what I'm going with. Good old FRA deep sea guide.
Alright, that's it. That looks like something. Wait, okay. Global gearing and oil data is foreign now. Okay. Oh, okay. Yeah. This is a foreign name.
Mm-hmm.
I don't
Oh,
know,
yeah,
I
that
don't know a
totally
lot of
looks like
I
it.
don't know a ton of taxonomy, but let's be global
Journey.
as a foreign name. Estimates in the foreign. So, right, but they're
No, they're.
it's under Physaria and then Foraminifera and then into the and they both Physaria.
Oh yeah, that's true.
Not much of a taxonomist.
Protozoa are like my weak point. I know
Yeah,
microbes
I know the folks
and I
that are
know
towards there.
animals, but the in between is where I'm pretty bad.
More of a phytoplankton protist. Show me pictures of those. I'm more familiar, but the heterotrophs not as much. Okay, so yeah, so it is a 4M.
Okay, cool.
It's interesting though that the Google search is like so. There's like it really doesn't have kind of images of this on Google that match, you know?
It doesn't know.
Yeah. There's just not. There's a picture in the publication that's similar.
Yeah, it's like a different kind.
Yeah. You can see them, they like glow like a beacon. You
Mhm.
can see them from miles away.
It's cool to imagine, like, without the ROV lights on, so much of this is bioluminescent and like what it looks like for them.
Yeah. It'd be cool to get a camera that's really good at catching the luminescent stuff.
People have done some of that from ROVs, but I think it is challenging.
We did it
Oh yeah.
before when we were in the South Sandwich Islands.
Hmm.
And there was like a few dive sites where we were just getting swarmed with krill,
Oh, cool.
and we had to turn the lights off so that the krill would disappear. But then when we had all the cameras off, like this top camera, you could just see little
Oh,
flashes
cool.
going off all the time.
That's awesome.
Super cool. But then when you turn the lights
I
on, you
didn't know
can't
our
see for
sensors-
krill. So it's like-
I didn't know our sensors were sensitive enough for that.
yeah, I don't know if it was just the sheer amount of it that was going on.
I mean,
Then
if you
it
can
was
see it
like-
with your naked eye, you'd probably be able to see it with the
Yeah.
cameras,
Yeah.
right?
Yeah.
Because they can definitely get bright enough for people to see.
It was cool. And I mean, you're seeing these krill from every conceivable
Mhm.
angle because the whole, like, everything you can see is krill.
Yeah, a lot of them I think release like bioluminescent stuff into the water to like the idea is the predator goes after that material instead.
Yeah.
But yeah, the type that I'm trying to capture is the like really dim stuff on the marine snow, and I don't know if you'd be able to see that
Yeah.
with these cameras. It'd be pretty tricky. Because for the images I'm getting, I'm doing like a 30-second exposure.
Okay.
Yeah, it's pretty dim.
Or something.
Might go get food.
Yeah,
I just need like 2 minutes.
safe. It's funny when they go like right into the camera.
Yeah.
Should have seen more.
Okay, that's
There
the
we
end.
go. Okay, Bridge, we can come to an all stop on that move. We're going to descend a little more.
Copy important.
So our next step is 750.
7, 5, 0. There's these weird little shiny things.
Yeah.
Want to look at it? No.
No, we can keep going. wonder if we want to make it brighter again.
Yeah.
Because it seems like it's gotten darker.
We can definitely do that.
Maybe the ISO.
This is probably the best thing to do first.
Okay.
See how we are. The more you increase the ISO, the depth of field gets worse. I want to say.
I thought that was what the iris did.
I can't remember. One of them. Should always say we tend to try and keep the ISO as low as possible and
Okay.
use the iris more.
Okay.
But for this
Then
instance, I'm not sure.
No, we can open the iris a little bit more.
Okay, Bridge, you can start that move again.
Go ahead, starting the move.
So Leo, do you want to do a click, open on the iris, and we'll see. Yeah, and then we can do that ISO if you want to.
No, that's not.
What do you think? Let's see what it looks like. It looks dark on the stream anyway.
Yeah, but then like this looks
monitor,
okay.
This monitor is the best one, I think. This one is more close to what the stream is, I think.
What do you think? I think that one is.
That one's
That one's
closer.
brighter.
You
That
think
one's
that?
brighter. This one's dark.
I think this one, I don't know. I think this one's better, more accurate.
I think more details, but that one is brighter. And more
Which one's the true one? Which one do you believe?
I don't believe
This one.
in anything nowadays with the AI. Can't trust my eyes anymore.
Well,
They're both the same feed.
give us a little bit more wire out, Leo. A little bit more
750, no?
winch. I know, but my belt is quite tight.
Yeah, because you went further lower than supposed to.
It's a way to come back up.
I stopped when you see. No 750.
Give it a tiny bit more. So it's tight.
What do you want?
Just a little bit more. Just a little bit more out so it's not quite as.
So did you change it already?
Yep, change it. Do you want to change it more?
Let's do a little bit more.
Okay.
Yeah, a little more open. Yeah, let's stick with that. I like that.
Yeah. The lights are all.
The lights should all be on.
You happy?
Yeah, I'm happy with that. Okay, I'm gonna start the transect. Yeah, it's weird that it's so much darker in the stream than it is for us.
Yeah. Well, we always have to try and monitor it as well because it looks real good.
Mhm.
Like these screens, and you look up there and it's so dark. And you're like, right, okay, I have to make it
Yeah,
brighter so that.
yeah, we just really don't want to overexpose because then we can't tell what things are.
Yeah.
So I think this will be good.
No. We shouldn't
It
have.
should be all the way out.
speed. It's
Yeah.
sped up a little bit since I started with that.
Were
It's
you?
like flying far.
Yeah.
Yeah.
Wait, so you sped up, you said?
No, I mean, it's sped up. I set it at 0.3.
Yeah.
And this is, it's up at 0.4.
This is okay. Basically, between 0.2 and 0.4,
Yeah.
I think is good. Yeah, we've got some comments in the chat about how much darker it looks, and yeah, some of that is the lighting we use for these transects, where we're trying to prioritize like seeing the most amount of stuff without it being overexposed. So it's a little different from the lighting we use when we like zoom in on something to get a really good picture of a single thing. But also there's just less stuff in the water for you to see. There's just like a lot less particles of marine snow because we're in the tropics and it's more what we call oligotrophic, so less productive. But you can still see there's stuff going by. There's definitely lots of animals down here. They're just less dense. That's a good one. It's a big one. Someone's asking if you frequently go to 4,500 meters. Obviously not on this cruise, but on other ones.
Yeah, I mean, yeah, it depends on the area. If it's as deep as that, we've definitely gone down and done dives at our maximum capacity. We've been at plenty of places before where there's been scope for going even deeper, and we've got to try and be like, oh, don't go too deep. But yeah, just depends on the area. But we've done it many times.
Are there? Is it more challenging to go that deep, or is it kind of the same?
No. I mean, it's the same for us, but it's like the limit is like certain components and stuff, and there's obviously a safety factor in there as well, but it's certain components that can't handle with any more pressure.
Does the temperature affect the ROV much? Because when we were up near the surface, it's so warm here, but then now that we're down here, it's a lot colder. Like, does the ROV handle differently?
No.
If it's shallow, it's gonna overheat.
Yeah, that's the main issue is the oil temperature.
Oh.
So if we're somewhere hot, we generally set our oil compensator levels lower because of the expansion and the heat. So everything will be running a little bit. We'll make sure that it's a lower level to compensate for the heat.
There's a limit.
We've been places where we've been working shallow, it's overheating, as in like we're getting alarms saying that the motor's running too hot because we've been really, really shallow, and the temperature of the hydraulic circuit running in really warm water is a bit of a trouble.
Cool off,
So it's happier down here in the cold.
Yeah, for sure. But then, I mean, not so much on this ROV. I've worked on other systems where in the extreme cold, the oil can get too viscous. So you can have trouble starting. You need to like preheat oil and stuff for ROV systems and for your launch and recovery systems and stuff, the oil needs to be at a certain amount, because if it's too cold, then it.
Would that be if you're like launching in like, you know, sub-zero temperature, like, you know,
Yeah.
for when it's like when you guys were down in Antarctica?
Yeah, oh, for sure. There's obviously different thicknesses of oil are used for different components and stuff, but then they have a temperature range which they're able to work at. So a lot of systems will have like heaters in them to preheat the oil before you actually have to run it through a pump.
Cool.
Happened to me even in New York on the project over there.
Oh yeah.
It was below zero and we had to start everything like 30 minutes before to heat it. Then be able to use.
Stuff like that. Preheat
The
the oil.
winch, yeah, only the winch. If you try to run straight away, just one moves.
High current and stuff, different breakers and all that.
That's it was good.
Like this.
I know there's some nice smellies. I like how the impulse of the smellies are
That was nice. It's like a treat.
You love the smellies? Pass around the smellies.
What is this?
Yours, yeah.
Smellies!
Oh wow. That's like very smelly.
Good
They're really
shit.
good. It's good stuff.
Very calming.
They're soothing.
Don't you feel that we breathe better after?
Yeah.
I need to steal some from home for when I get a cold.
Did you find it easy in yours?
It's in Thailand.
No, this is from Tim.
Yeah, I know. But
I know.
Well, you can get to know.
I found in Brazil what it's like
Yeah.
Show Vicks.
$30.
Smell it. Huh? Yeah,
Basic.
same smell. Show that stuff you get. Vicks. Vapor rub.
I was gonna say, if I go to San Francisco,
Our dealer is gone.
Yeah, exactly.
I just love how we had the
Spencer.
dispenser of smellies. I had dumped when I came on board. I had dumped all my leftover Halloween stuff in there.
Yeah.
I knew if I put it in there, it'd be gone eventually. And it was gone in a week.
Be gone. I was going to say it'll be gone fast.
Yeah.
You had me
I
at Spencer.
I knew I could rely on Julia's sweet tooth.
was a good fish. Just went by.
Yeah. First fish we've seen, is it?
Oh no, we've been seeing plenty.
Oh, yeah?
But like the shiny things, those are fish.
Goodbye.
See?
See you.
See you.
See you.
Another one of the guys.
Mm-hmm.
See them so far away.
But then they're so delicate.
Yeah,
I think we'll be able to catch one of those.
for sure.
Will it still be there when we come up?
Mm.
We'll see.
Yeah, those things should be pretty straightforward to catch. You even suction one of them up, and then you'd be worried, would you?
I'd just be worried all the threads would come off and it would kind of fall apart, you know? Like, I'm sure you could suction it. It's just, I mean, they seem really delicate.
Yeah.
So there's a question in the chat about whether this lower productivity area would have lower diversity, and it's like kind of complicated. There's overall trends in diversity where like generally places with lower productivity, like sometimes they have lower diversity, but also sometimes they don't. Diversity kind of like increases with depth. Oh, okay, I'll finish that in a second. Okay, so that's the end of that transect. The next one is 875.
875.
Mm-hmm.
Bridge, we can come and I'll stop on that move just now. We're away to descend further.
Copy that, coming to
Anyway, diversity patterns are like not as simple as just like a total 1-to-1 correlation with productivity. Because if you think about like coral reefs are in relatively low productivity areas of the ocean, but they're super diverse. So it also depends on like what type of animal you're looking at. Like fish diversity might follow one trend, but then like shrimp diversity might be a different trend. So overall, I don't know what the trend will be. That's part of what's going to be cool about this cruise is we're doing these ROV transects and then also the like net tows where we get a bunch of fish and also crustaceans and other things, and they'll be able to analyze that data and figure out like what are the differences in diversity and abundance. So it's a good question that I don't really have an answer to. I think it's a jelly. Yeah.
Look or no look? Just keep
No,
going.
no, look. You can keep going.
Okay, Bridge, you can start that move again.
Coming there, specimens in the move.
Okay, it looks pretty good. I'll get started.
Yeah.
Hmm?
It's like a little nudibranch or something.
I think it was a comb jelly. So like when it has the little wigglies on the side, yeah, that's usually what that is. I don't know. I wish we could stop. I think it might have been a fish. Oh well, it's gone forever now.
Scattered fish or something.
Yeah, something like that.
Yeah, how you like everything.
But
You
when we're
know-
analyzing the transect, we'll be able to zoom in and get a
Yeah.
guess.
You know that is the type of fish that would be like, right, okay, stop. It would turn to look at it, and as soon as you get it framed up, it would just go.
Yeah.
And be like, all right.
A lot of the ones that hang like that, they'll just go down like so fast to get away. Those shots of those snipe eels were really cool though. I'm surprised they behaved for so long.
Makes our job a lot easier when they do behave.
They probably
Pose
prefer
for the camera.
jellies for that reason, I would
Yeah.
guess.
I've seen some docile fish before. But then when they get spooked, you've got no chance.
It's almost easier when you get deeper because they're not usually the migrators. So they're like mostly ambush predators, and most of the time they're just hanging around and they don't have a lot of energy. So even if they do dart away, they're not gonna like keep going for very far.
Yeah.
You can kind of just like wait for them to get tired.
I've caught a good few fish
Mm-hmm.
with nets and the
Yes.
manipulators.
That's
one of my-
wild.
One of my favorite things.
Like that's a fish right there. Ooh. Hold on. Try this. I'm worried we're a little overexposed, but then when I look at this, it looks fine, so I don't know. I think we should just keep with it, but it's hard to tell.
I'm just happy I've got my depth dialed in.
Yeah.
You know, like those
Whoa.
straight lines.
That's impressive.
What?
Look at our depth. We haven't, like,
Straight
so
line.
level.
It's the small things that get you confused. I've been tinkering with its gauge, just like, right. And it creeps up ever so slightly, creeps down ever
Yeah.
so slightly.
Here we go.
Okay, Bridge, we can come and all stop. We're going to descend again.
Coming full stop.
Going all the way to 1,000.
Roger.
To keep that that same depth, are you having to thrust down a little bit?
Yeah, so when we use the auto depth function,
Mm-hmm.
it kind of hunts a little bit, so it'll find like a point, but then it'll kind of move up and down, and you
Yeah.
end up getting like a less stable sort of depth.
Mm-hmm.
So with this, all I'm doing is just adjusting the amount of thrust, because we're ever so slightly buoyant,
Yeah.
and if I just dial the thrust down enough, it either lets us sink really slow or come up really slow, and it's just like, just find the sweet spot.
Mm-hmm.
Just make a little game of it.
Anything to keep you entertained.
Yeah.
I'm gonna see if Anitra can come here from noon to 4, and then I would do 4 to 8.
Sure, sounds good.
Alright.
I think we're coming up at 6, right?
Oh, is that it?
It said 1,800.
Oh, okay.
Am I making that up?
I don't know.
Let
I'm
me
just,
see.
yeah, that,
Yeah.
okay. I mean,
Yeah,
the schedule
1,800.
keeps changing, so.
I think 1,800. So yeah.
Yeah, I would dare say we'd be on deck before 8. 'Cause
Yeah.
I think Doug will be going off shift on or before then.
Alright. I'll message Anitra and see. Have you seen anything cool? Or is it pretty empty?
I mean, no. There's actually been, I feel like, kind of a lot of stuff. Like,
Really?
definitely some fish, siphonophores, a lot of variations higher up.
Oh, cool.
No, there's definitely plenty of stuff.
The ocean is still alive.
It is. The particles are a lot smaller, but
Uh-huh.
there's clearly still a lot of them.
Yeah. Cool.
Yeah. We got a really nice zoom on one of those flams.
Oh, cool.
Yeah.
Nice.
Sneaked one in on the way down. Or right to the
That's-
transect
it's
mode
allowed,
again.
it's allowed.
Yeah, I opened the iris more, but I'm worried it's a little
Yeah.
too much like maybe it's overexposed,
mean,
but
it's
I don't know.
Fine.
It just depends on what screen you look at.
Yeah,
like
totally.
this is like,
It's
oh, is
kinda
that too
hard to
bright?
tell.
But then you look
Most
here.
accurate screen right here.
Okay.
And we can look at this thing just to see if we think it's overexposed.
It looks
You think it's okay?
fine.
Okay.
I wouldn't do it any more than that.
No.
Are we done with the survey?
No.
Oh, I was just gonna mess
I was like, what do we see? Is that fish or is
Ah,
Okay.
this is just a camera test.
Yeah, that's all.
Nice.
Ooh, nice. I don't know what kind of fish that is. Oh.
Anisha, could you do the noon? Could you relieve Lee at like some time in between lunch, and then I can do that later in the afternoon?
Yeah, so I was here to relieve you for lunch if you want to go eat, or if you'd rather
You
eat
can
after
eat
me.
now and then you can come.
You want to come back at noon? You want me to come back at noon? Okay.
That works.
All right.
And then I don't know how long you want to do this for, Anisha, but then I just kind of like when's the end of the dive?
It's coming out before 8 o'clock. Before
It
eight,
says
like
6
eight.
on the schedule, just so you know.
Oh,
What, like it says
that's
1800.
dinner time. So.
Did you mean 8, but you wrote 1800?
No, I think I was like unsure when people wanted to come out of the water, so I put down a number. But
Well,
we could
if
come
you
out
could
at 8.
do like noon to 3 or noon to 4, then I could
That's
do
fine.
4 to 8 or
Yeah.
3 to 6 or whatever.
Yeah. Yeah.
Oh no, I can't do 3. I have some Zoom meetings this afternoon. That's
Okay.
why.
I can also come
That's fine.
back.
But I
I can do whatever.
come back at 4.
I can do any whatever amount of time. I mean, I might have to be called away a little bit, but I'm not sure about that. So I can. So should I put it onto the schedule for till 8?
It's up to you.
Or do we want more time to maybe collect things, or do we want to? We don't have to bring it up during dinner. We can go till at least 6:30.
The next thing that's happening after this is another mock nest.
No, this is
3
a
hours.
bets.
And what time
3
do
hours.
those want to go in?
It's a 3 hours of it.
Yeah, there's a bunch of there's like 3 zooplankton toast tonight,
Okay.
and that's the only thing I think. We don't have the daily plan in here.
I'm just trying to get it up here.
I'm gonna go eat lunch.
And I should go eat lunch too, so that you can eat lunch with me.
Sounds good.
Okay. And we can stay until 8 if the ROV team is okay with that.
Have to check the dog.
Yeah, it was an 8 a.m.
Yeah, so we could be out of the water by noon. Or we could be out of the water by. We don't want to have it be in the middle of dinner, so it's either going to be 5:30 or after 6:30. So
It's always a popular choice.
Let's do 8.
Okay. But I'll make sure that the thing reflects that, and I'll come back and include you.
Watch drainage. Vibrating sound as well. Has that been all day?
To be honest. Okay, Bridge, we can start that move again.
Copy that.
Okay, are we happy?
Yeah, we're happy.
Okay.
We're happy if you're happy.
Yeah, let's get it started. Looks like you're going down.
Look how close.
How come depth is different from what it says there?
I know that.
Is it on different parts of the ROV?
We've got a few different depth sensors.
Mm-hmm. Which one's the closest to the camera?
Nah. I don't know which one we're using right now, but I'm taking that. That's a win.
Okay.
It's a win. Using our CTD depth. We've got a few that we can use to reference for this. I don't know what this will be. One of the other ones, the Pago maybe, or
looks like the one that's recorded in C log is like the one up there.
What you looking for, sir?
Oh, there's like different depth measurements that say slightly different things.
Yeah, in green C there are no corrections in it. It goes in and reads it. So we pull everything off of the multiplexer top side and then apply TOS 10 corrections to everything. So in Grafana on the screen go from the side view. But on Grafana and in C log they're all the corrected values that should be very close. Unless there's USBL depth, there's sprint depth, and then sprint corrected. There's arrow corrected, CTD, CTD corrected, UBSVX, UBSVX corrected, and mini IPS.
I understood like a fifth of those words. But thank you.
We take depth very seriously.
Yeah.
Green sea, however, does not.
We're just like, as long as it's kind of around 1,000 meters, that's good.
But that one, because what are you on right now, Caro?
CTD.
Okay. So that is a corrected depth already, yeah.
My main focus is how straight that line is.
Means you're doing your job.
Yep. That's really what we care about with the transect, is it being level, not the exact depth.
Consistently something.
Yes.
Nice.
Because this is theoretically one of the outer edges of one of the depth bins from the Mach Ness. But like the Mach Ness doesn't stay at one depth, so.
On your last Mach Ness, which depth was the most fruitful?
No idea. I have not looked.
No.
I'm not really a part of
involved
those.
with that.
No, that's like the one thing on the ship that I'm not part of, so. I just like stick my head in to see if they found anything cool.
What's the coolest thing you've seen so far? You've poked your head in.
I really like dragonfish, and they found some really cool ones of those.
Very cool.
There's like the loose jaw dragonfish, where it looks like their jaw is like barely even attached. Yeah, those ones are fun. They got some cool squids too.
Squids are always cool.
Mm-hmm. Mm-hmm. I think so. Or maybe a doliolid.
That's a massive siphonic.
Oh, wow, yeah.
How long have you got left on your alarm?
30 seconds. Oh. That's so funny.
Five backwards.
It's huge. Find it.
12 seconds.
Oh my god. Bridge, we can come and I'll stop on that move.
Copy, coming to also.
See if you can find it.
There it is.
Oh, nice. Wow.
You want to do some lighting, Leo? Ooh.
So bright. I can't find it.
What do?
Wow, it's so long. Uh-oh. The swimming bells are all coming off.
What's going on here? Like, stays healed. Just do a quick down it. Hold on 2 seconds. Let me know if you're zooming it in or not. Cats in the view.
Yeah, let's look at that. Might be an ostracod or a squid.
Tell me if you're zooming it real so I know not to get any closer.
Oh. Oh, it just keeps going.
$12.50 is it?
Yeah, that's the next step.
Yeah. That's what's literally saw this right at the end of the transect.
Okay, so we're going down to 1125.
No,
250.
1250.
Right. Adios.
Is that the lighting you kind of were looking at? All the lights are on? All the lights are on.
Yeah, all lights on. The ISO should be about 500.
Yeah, got that.
And then iris a little bit more closed.
A little more focused. How's that?
I think that's good. Yeah, like
Yeah,
that.
yeah,
Yeah, there.
okay.
That's good. Yeah.
Alrighty. What do you get down there? 1250. They do the weather system. It was broken.
But it was broken.
Yeah. Going through the interface was broken. But we still were able to get some footage and release it. Stable port. No
Yeah.
big thread or anything.
What?
Nothing that was tight.
The port number?
Yeah. You don't need anything.
It's very warm.
Our time has come.
Excellent. Sorry. So this camera settings should be good. There's just 2 more transects left. We're heading down to 12:50 now. No.
All right. And then I have to do the logging.
Yeah.
Okay.
If that's okay.
Yeah, no, I mean, I can do, I just want to remind, I have to remember.
Okay, yes.
When is this one over? You are timing it?
We're not doing that. We're going down right now.
Oh, we're going down right now. Okay, all right.
So we're heading down to 12:50 once we're there.
Okay.
But yeah, I've just been doing like checks to start and stop.
Okay.
Yeah.
All right, thanks. I brought dark chocolate down. Well, where's Ian? Oh, he's gone. Oh, there you are. I brought some chocolate. I brought dark chocolate.
Oh man.
Do you guys not like the dark chocolate?
They like the best.
It's the best? Oh, good. I brought the right kind.
I'm a milk chocolate man myself now.
No, it's not even chocolate. You're just laughing. Would anyone like some dark chocolate?
I don't think not right now. Alright, Trans, have a good.
Alright.
See you later, Enjoy.
See you
Enjoy your
later.
Gym time, buddy. Thank you.
I assume this mic is on.
I don't. Are the mics on, right? Sometimes they're all-
Just the beep.
Just yours and you try.
That's mine, okay.
Yeah.
I'll just introduce myself. Lee just left to go to lunch, and my name is Anitra Ingalls. I'm taking over right now, and I'm from University of Washington, and I'm a microbial biochemical oceanographer. I'm gonna get my.
I don't know how old that comment is on there. But your comment asks if you can go down below 4,500 for long. I don't know how old that comment is, but we don't test that. Don't push it past 4,500.
We're doing 15 minutes at each interval, right?
Yeah.
Calibrating. Have you seen anything good lately?
Just sit down. How's our tracking? Excuse me? How's our tracking? Good. Well, because for whatever reason I restricted back 15 years if I'm not going to say why. We're pretty solid in all 7 back.
And there's a question about currents. It really depends where we are. At this particular location, the currents have been really, really low. So even at the surface, they've been 0.1, 0.2, 0.3 knots. All the way down as far as our ADCP measures. So there's very, very little amount of current.
Good afternoon,
Can we start moving due south at 0.6 knots, please?
So shall I start the
0.6
transect?
is starting.
Thank you.
Okay, we are at 1250. Start. And some of our other stations, the surface currents were like 1 knot, and this one they were 0.1 or 0.2 at the surface. And I've been some places where it's 2 or 3 in the open ocean, like at the equator in the Pacific, it can be a few knots. Makes it very hard to do anything in those currents because anything that's tethered to the ship is going to go sideways instead of vertical. Friday the 13th.
It is scary movie night in the cinema.
What?
Scary movie night in the cinema.
Scary movie night. Yesterday seemed more like Friday the 13th when everything was going haywire, but today's been very smooth. Okay, knocking on wood. Ooh, wow. That was pretty cool. What was that? The jelly? Yeah, I think you're right. Little jellyfish.
Grace, can you sit down just a touch more, please?
Red ROV.
Right.
Can you make your speed 0.5 knots, please?
Slowing down.
Thank you.
I'll say 0.5 now.
Thank you.
Sorry. Yeah, sorry. I was just looking at it, I was like, it says 72 to 7.
Funny, a lot of things do just seem to be sort of suspended there, totally still until we come along. Like they spent, I wonder how much of their day they spend just in suspension, doing nothing.
Unless it's supposed to. Especially just got to this.
Right, yeah, they don't want to use it if they don't have to. We have that term for the microbes in the places where they're not very active, that we call them the undead, because they're like not dead, but they're not really doing anything. So they're kind of dead, but kind of not.
Where's your RV?
Right.
Yeah, you can come to a slow stop here and be getting ready to go down to 1500.
Lobby, come to stop.
Are you having to propel the ROV more so now because the currents are so low, and before we could almost sit in place and have it go by us?
Pretty much.
Yeah. And so then the ship has to keep up with us.
There's some savings, but
Yeah. Yeah.
How far have we traveled since we began?
Since we began?
just
Yeah.
15
No
minutes
idea.
or total.
The top, yeah, I know at the surface.
It's gonna be quite a ways.
So this is where we were this last 15 minutes.
Mm-hmm.
So
It's probably been about 1,200 kilometers, or 1,200 meters, so 1.2 kilometers.
And were we going against the current?
There is no current.
There's none down there? It's zero?
Really.
it's negligible.
So you're just driving at 0.5.
I'm going at 3 meters a minute, so you have to
Per second.
sorry, second. And then
I see. So we've gone about not quite a mile, or 1.2 kilometers since we started, huh? Interesting. Yeah, this is nice conditions to be able to look at things up close because it's so still. We were having trouble when that one location, the currents got really strong in the upper 500 meters, and we couldn't. It was like chasing after stuff was hard. Right?
yeah.
Yeah.
Had to move with it.
Pressure on the sentence where one max uses, but
Yeah.
All right, 10 seconds left. All right.
Alright. Heading down to 1,500 meters.
Yep. Stop. Oops.
Got some quacking ducks.
That's my quacking duck.
Quacking ducks for a nutrient.
That's me. If you see something amazing, you can stop.
I'll do that. Just no cool actions at this depth, but we can, on our way down, but we can look at stuff on
Oh, I guess
it's worth it, maybe consider something.
it's worth considering collecting at this point because we're so far down that it's not going to be. I think, it's not that long before we're starting to come up, and we'll be at our maximum depth too. So.
1,500 our deepest we're doing.
Yeah. The last 15 minutes of torture.
I just woke up, so this is actually kind of nice.
Ease into it, Chris. Ease into it.
Ease into it. It's probably not easy to do those really difficult maneuvers when you've just woken up.
Sometimes. When you go by muscle memory and knowing you're thinking.
Yeah. Sounds like I share a ringtone with someone in the audience. My alarm to wake up is birds chirping, but timer is the duck. when the curling matched?
USA was up. I mean, Canada, we're talking like it was over, but I'm not 100% sure that it was. They had a big 4-point round. That was the one that I saw. There were 4 points.
Wow.
A little quiet. It was just 7.5.
Almost to our last depth. Like four, I think. I mean, do you have a preference?
All right.
Yeah. Okay, we're gonna start the final depth. Video transect, start.
Yeah, can
We're
we
going
zoom that and move
1500.
0 at 0.5 knots, please?
Copy, 0.5 mate.
Thank you.
All right, we're rolling.
Is this the deepest one there? Yeah, milestones for these days.
What do you think that was? We'll never know. In 15 minutes, 14 minutes and 10 seconds, we can find out. I thought it looked either like a squid or a shrimp. But so I guess we'll have like 7 hours left, 6 hours left. We could spend maybe we could plan to spend an hour or something at each of 6 depths. Maybe. Or we could just be slowly descending kind of the whole time. I don't know what you guys think is the best way to encounter things.
Usually what we'll do is come up with just at a steady speed,
Mm-hmm.
looking direction we're going, and with this camera.
Mm-hmm.
And then
So you
this-
point it up.
We point this camera up going up, so we can see if it's doing down before it gets here. We have to like react this fast, and then we can come up, go forward if it's certain, we just mess around with it. Do you don't care if it's at 1250, you just want it something you want to know for questions.
I mean, just the best way to like sort of encounter things that like, without scaring them away first, or just
Yeah.
the best approach for you guys to be able to then zoom in. You know what I mean?
I'll say just first to slowly come up, and we got a lot of time.
Okay. Because we could cruise along at a single depth for a little while, or we could just
Yeah.
very slowly come up, so that we're sort of slow and steady, whatever you prefer. We're pretty, we're just hoping to see stuff, and you're more experienced than I am about how to best
have
do that.
layers you're targeting here, like on the previous sites?
No, I mean, yeah, we do. I mean, if you look at the acoustic, is that the up-to-date acoustics? The timestamp doesn't seem right.
No.
I don't think this timestamp is right. Like, because this says 11:45 a.m.
Oh, yeah, our EKA is not on.
Oh, we should turn it, yeah, we shouldn't record, but we should turn it on.
Okay.
And then I can see, yeah, we're not really, we're happy to take a specimen from anywhere, but we might be more likely to find something in the layers where they're showing animals in the acoustic data.
Okay, so yeah, so we can
Spend a little more time at
come up
those.
and if we see somewhere where it looks a little more dense in the specimens,
Yeah.
and then we
Yeah.
around.
Okay, so here's the acoustic data now. On that screen. Is that, oh, she's still Whew, that wasn't one of those guys, wasn't it? I just barely saw it. One of the 4Ms.
Before we start looking for
Can you
zoom
zoom
in,
out?
just to show you it's not that weird spot where it might be this. So just take a minute to do it.
This is now. Yeah, so like between 1,000 and 750 looks like there's a lot of stuff, and then somewhere up around 600 to 500 maybe. So we can spend a little extra time in those areas. I mean, that doesn't see everything, so, you know.
ride your RV?
Seems every time I calls, every time I walk forward, someone calls. What's that, mate?
Can you reduce your speed to 0.5, please?
Got it, man. That was reducing everything.
Thank you.
That was a worm. What kind of worm? Was it an arrow worm? Or like a polychaete?
Yeah.
Little worm.
Little worm. I am amazed at how many things are moving around down here.
Good grass living into it.
All right, 5 seconds. 4, 3, 2, 1.
Red jar,
Quack.
can you come to a slow stop, please?
Alrighty. I'll use your hands.
All right, we're ready to have some fun now.
Autofocus is illuminated.
Did you get chocolate, Sophia? Did you want some?
What?
Did you want some chocolate?
Chocolate.
It's dark chocolate.
No, thank you. What kind is this? Is this your personal
No,
stash?
it's not. It's just
What
from
is
the
it?
galley.
Thank you.
Mm-hmm. Just brought it down from upstairs because I need a little pick-me-up.
Do you want another pick-me-up?
What have you got? That sounds intriguing.
You want to do this one with any specific depth?
I've got smellies.
What? Yeah, you guys are.
It's really relaxing.
Wow, it does smell
Smellies.
good.
You want some smellies?
No, I've got my own.
RV bridge, that's
That'll be the last
Thank you.
duck to quack.
All right, Anitra, what's the strategy? You
So-
want to come just up in the water column, or do you want to keep coming up and forward? How do you want to do it?
Yeah, we discussed. I mean, if you have a strategy that you think works well to kind of sneak up on things and be more likely to see interesting things, that's fine. But we can slowly come up and move a little forward just at a speed that is comfortable so we could stop if need be, to, for you. And then we probably want to hover around these depths for a little while where we see stuff in the acoustics. So,
Okay.
like, sometime like maybe starting around 900 and going to 800, maybe we slow down a little bit or
Okay,
spend a little
so
bit more time,
You
and
wanna
then
start working up towards that now.
Yeah.
Forward, just creeping ahead.
yeah, you can move. Really slowly moving up, or we could also do it where we stay at this depth for like 20 minutes and then move up a little bit and go.
Okay, that's fine.
It's like I don't.
Just go slower.
Yeah, so that you guys have a chance to
I'll make the vessel speed.
because I think the speed we were going, it was a little hard for you guys to actually stop in time to see. Is that true?
We're pretty much more maneuverable now without the effects of the current. So
Right.
yeah, we got a little bit more maneuverable, but
Yeah.
without that. Effects.
So we have 7 hours till we surface.
We're ever so slightly positively buoyant. So what I can do is I can just kind of go around and let it just come up naturally.
Okay, that sounds good. And I guess maybe you're more likely to see stuff if you move through it a bit. So
We'll creep forward as well.
I mean, we see a lot of things in the survey that go by, and just if you're going so fast you can't stop, then that's not so good, right? Mm-hmm.
So
I wish I had brought more of my own chocolate to, special treats.
Are you interested in a niskin anywhere?
I don't think we're gonna fire any niskin bottles at this time. My team is just not gonna be able to be there to filter them. I think we were the only ones interested in them. We did like 4 CTDs yesterday, so
Not enough water.
we fired enough niskins. They're done. They're tired of filtering water down in the lab. We did. Yeah, we had like a record-breaking day of filtering water yesterday.
Pools.
What might have been cool up there? I don't know what that was. I should pay more attention. All right, focus. So I'm kind of curious about some of these brighter particles.
Yes, I'm trying to look at it.
Yeah.
Focus on it.
Oh, is that the
It's-
same one?
Yeah. It's
Okay, so you went back and
super
found it.
small.
I know. It sort of just seems to be glowing a little brighter than everything else. I'm kind of curious. I don't know what your limits are for how small a thing you want to try to chase after.
I mean, if I can get a good look on it.
Yeah.
No, it's out of focus. Let me see what it is.
Yeah, maybe it's too small. I don't know.
I mean, it's like.
Yeah, that's about the size of a protist. So if it were a protist, it could be interesting. There's some. Is that a siphonophore?
Yeah.
this is the fun part.
Yep.
Ooh, was that a larbation or something? It really disintegrated.
All the. Did 3 dots there. Since you're connected, I think.
You think they're connected?
Yeah.
Up in the corner over there.
Can't focus on
Can't. Yeah. Too
They're
little.
just-
Yeah.
they're just
So.
so
we'll-
small. There's so much other stuff
Yeah,
in the
yeah,
water. but
yeah.
it's
I think those are
super
small.
brown.
Yeah, those are smaller than the forams we were seeing, and also probably smaller than the Phaedarians.
They definitely are moving in concert with one another.
Yeah, interesting. Whoa, that's a What was that? A larbation? That looks interesting.
Oh, Lee's dad is in the chat.
What?
Lee's dad is in the chat.
Oh, I think this one isn't scrolled all the way down, so I can't see the most recent.
Fix that.
Yeah.
Ooh, that looks like it has spines, does it?
Yeah.
So maybe that's a radial area we've been searching for. Or maybe not. It's a jellyfish.
Yeah.
Looks so cute. Ooh.
Ooh, that's very pretty. I'm not I don't think so, but I mean, how big is it?
It's, if you look in the stick camera.
What? Oh.
Stick camera.
Oh. I mean, go ahead, sure, yeah. And I mean, we haven't filled all 6 jars yet
Go to 2.
in the dive, so sure. Okay, 2. Yeah, so I should log a biological sample. If it actually goes. Yep, that's in there.
In there? Yeah.
Yep, jellyfish.
I don't know if it's still in there.
What depth are we at? We are at 1473. Jar 2.
I don't think it stayed in there.
Nope.
It was definitely in there.
It went in, but went out. Okay, never mind. Lee was here, and now I'm here. My name is Anitra Ingalls, and Lee went to lunch. But Lee was here all morning. Sophia, do you know what kind of jellyfish that was? What?
I don't know how to say it, but it's like
Agina jellyfish?
Yeah, I think someone also popped it in the chat.
Oh, okay.
This one.
Oh, okay. Uh-huh. There are people on this ship that are better at identifying things than I am, but they are busy in the lab identifying things from our net trawls, so I'm here with you instead. I'm really interested in the teeny tiny things, the particles and the protists, the single-celled organisms.
Like those things.
This one could have been a larvation. We always seem to do these ROV dives when the team is in the lab processing samples, and that's because it's an activity that doesn't require a ton of science party to be involved, and so we can do it when a good part of the team is in the lab processing samples. We will be taking those images though and processing them and identifying things and doing a quantitative survey of all of the animals. So we will be using it, but right now the people who can do that are not in the room.
Where are you? There you are. That right there. Let me see if my set just didn't know where my set was looking.
Is that a copepod? Oh my gosh, that's a copepod over there. I think that was a copepod. And now we've got a worm. I think these look like, is that a siphonophore? All right. Oh yeah.
Ooh, it's pretty.
Yeah. It's similar to one we saw before that was all kind of wrapped up on itself, I think, in a spiral. This one is a little bit more extended. Is it giving off all that?
Yeah.
Oh, wow. It's like exuding something. Shedding something. It's wild. Nice. Wow.
Alright.
Yeah.
Getting too close to me. Where's this thing? See everybody.
That looks like an arrow worm. Ketignath. Ketignath. Not swimming away.
He's right there.
Oh yeah. We do get a lot of those in our net. There it goes.
Super small. Side of my camera now.
Maybe come up to 1,000 slowly. Must have started moving faster, but we haven't changed speed. Oh, because we're going up? Is that why your camera's facing up?
Yeah.
Ah, gotcha. That's another one of those small things, but that's too small for you. They're really kind of glowing.
See that in there? It's just this.
Yeah, I know, they're too small. Yeah, I'm not saying you should try to do that again. I think there's no point, but it's interesting that sometimes there are these little particles that do seem bright, very bright. Do you think when you see these particles moving and they look like they have tails, they're actually tails, or is it's not just streaking of the image on the
No.
screen? Those actually have
Yeah,
tails.
like that one right there. Top.
Like right here, that guy's swimming. I guess they have these tails that. Yeah. Okay. So those are real.
Yeah.
They're like little krill or something, right?
Yep, yep.
Okay.
We had the krill cruise where we didn't see very many. The one we saw that day.
Uh-huh.
Collected like 50 to 100 more butterflies.
We were able to collect the krill.
Yeah, but they were tiny. That's what that goal was.
Uh-huh.
And then the next cruise we were on, they were everywhere. Like we couldn't even work sometimes because there was so many. We had to turn all the lights off.
Yeah.
And where was that?
South Sandwich Islands.
Wow. Oh yeah, because that's the Southern Ocean-ish. I was like, all right. Wow.
So bad because
Turn on the suction sampler to get something else, and every jar would come up full of krill.
Wow.
Every jar.
Wow.
It was crazy.
Wow.
Yeah, poor lady, the doctor beforehand, that's all she wanted was krill. She had all kinds of, she had a trap she made and everything. Maybe got a handful.
Wow.
we sat on the seabed. You know, we were trying to cook for her, and I had the manipulator. I was just like. And then literally the next cruise, they just
Couldn't get away from it.
Yeah, they would just follow us in swarms.
Wow. Yep. That's the place to find krill. Down south. I mean, I'm amazed at how much there is here. This is the most nutrient poor part of the ocean you can go to. I mean, there's other places similar, but there's a lot in the water for that deep, 1,500 meters, and we're seeing all these krill swimming around. It's amazing. Or not, maybe not krill, but some kind of crustaceans. Oh, what's that? Is that one of the 4Ms? We could try to capture it. No, maybe not. Maybe it's just like more like a larvation. I don't know. Yeah.
I mean, it looks like it has something solid in the middle of it.
I know it did, but it looks a little more. You can keep going. Now you're curious. It looks kind of globular, like a larvation. Yeah. It's the kind of thing when you see that and you think about how we normally sample water, where we collect the water and then we filter it. It's like, what happens to that on the filter? It just goes right through it, but it's actually kind of a particle. Yeah.
By the time I got under our jars, it was under impossible to see.
Yeah. If it was actually a forum or a radiolaria or Phaidinium, I'd want to collect it. Phaidarian, I mean. But it's hard to tell. we tend to divide up the particles into size classes and think about how fast they might sink based on their sizes, but you can see that the size changes when you put it, when you touch it, it changes the size. Well, you don't have to touch it to change the size, you just have to give it a little bit of a, you know, current. Woo! There's a siphonophore.
And jelly.
And a jelly.
It's one of those things like observation of the experiment changes the outcome.
Yeah, right. It's hard to observe things without altering them.
Where are you, dude? I see you in my set, but not in my science. It's working out there.
There's another connected thing.
I think I came off of that.
Oh.
Yeah, I think it's super far away, super fragile. So I'm just gonna
Yeah.
be- Okay. So, I think that the brighter things, everything I've gotten decent look at is just some of the longer, bigger animals, just obviously far too light, but
Right. That's a there goes a copepod. I think that's a copepod. I've never seen such big copepods. Huge.
bigger than normal.
I mean, copepods can be so small you can barely see them, and these ones are like, I mean, you know,
Half a
a
centimeter.
few millimeters, yeah, and just big. Especially at our last long station, but this one also has some big ones. I'm just used to really tiny copepods. a lot of different colors too. There were the normal sort of orangey, pinky ones, and then a lot of times when they're really small, they can be clear, and you can barely see them because they're kind of clear colored. But then there's also these like ones that were blue and black, grayish in our samples, all different colors of copepods.
What would alter their color? Just look thicker skin, or?
I mean, I think they accumulate a lot of their pigments from their food, but sometimes they make them, and I think they're different colors depending on their habitat. So they might want to be invisible in a certain environment, or they might want to reflect blue light because they're on the surface, or not surface, but where there is blue light still. And then I think the other ones just collect. I mean, you can't really avoid accumulating carotenoids that are the orange and pinks and yellow colors if you're eating that food source. So I think a lot of it comes from their food.
Yeah, that's like all the things that you can see that would good to have longer in the shape, but definitely if that's what they're shaped like. So
Yeah.
Yeah, it's not
Like that one's got like a pretty long tail right there. They look like little tadpoles.
Yep.
There's the one, yeah. I kept trying to figure out whether it was real or not, so I think it is.
On your turn. So there it goes, turn a little bit. Yeah, there it is. So as it turns, it looked significantly longer than
Right, yeah, when they change orientation, they change shape. Yeah. So I guess when these images are processed, you'll really be able to see those, the shape of those if they're in focus, when they're in focus. It's this guy.
And that's just stuff that works together, or is it like one cohesive animal?
I think it's like that one we just saw, but only a little part of one, or a small one, because it has the same stuff kind of around it, all that sort of, clear but still attached stuff. Well, maybe it's different. Yeah.
Okay. Yeah, it looks like this so.
Yeah. This time I was sitting at breakfast when the ROV went in, so I could see it. I looked out the window and I was like, oh, there's the ROV. So I got to watch it descend from the upstairs rather than from down here. It's kind of fun, especially in these clear waters. You can see, so far down that you're able to see it still for a little while.
I definitely heard it. Few notches from
Were you sleeping?
it. I was.
You were until the ROV. Sorry. I've been on ships where the CTD starts going out, and you're just like, oh, I was sleeping. Someone had to do a CTD at 3 a.m.
I was actually alright with it because I knew we were gonna die, so I was like very sure I think safety going on. For better or worse, my room's right next to an RV, so it's just like, look out my window, see if it's there.
Right.
So I can hear that door.
Did you always get the same room when you come on board?
Yeah.
Really?
I have a back-to-back car, so it's swapping around, so it's easier.
I see. You keep the same room and just, yeah. Do most people have that same situation, or they switch rooms?
No, most of the crew, has the same room.
Most of them have the same room? Oh, really?
There's some variations with the science department right now because there's so many of us relative to the rest of the crew. So we move around depending on work. Like engineers will have interface engineering, separation engineering, chefs, personnel.
I'll be back in here for the show. So I think Mike is gonna help us out presenting.
What's that?
I think Mike was gonna help us present with you.
Perfect, we'll be in
So we'll be in here shortly. Cool.
34 minutes.
Susan?
Will any of the RV team be here for the next cruise, or there's no RVing, so
Yeah, there will be 2 members of the ROV team. One just to take care of a few things in the ROV, and the cruise after that's pretty substantial ROV cruise, so we'll do a lot of preparations.
I see that.
Doug is looking at a to-do list for me. I think Mike will be, once we go home, he's filming for a few days and he'll come back on for the next cruise, and then back-to-back guy will leave me.
Where is home?
I live in Florida at the moment.
Where in Florida? Where in Florida?
Neptune Beach, North Atlantic coast.
Okay.
South side of Jacksonville.
Are the beaches nice there?
What's that?
Are the beaches nice there?
The beaches are really, really nice. The sand is really nice. I live right by the St. Johns River, so the water's a little bit murky to be helpful with that. But yeah, the beaches are beautiful.
I don't think I've been to that part of Florida.
The water, I think, is probably pretty on the Gulf side, maybe. But
Do you get sargassum on the beaches these days?
there's some, but not too much.
Too bad. too, that's awesome to be found. Little red. Yeah, I'd maybe just keep them and then take pictures of them and then show them when they FD the other ones. You can kind of associate them. That makes sense. Look at right there. Oops. Is that a Phaedarian or is that something else? I mean, sorry, larvation. Yeah, so maybe just keep going. We did there's a question about whether we've been net trawling. Ooh, there goes something. We did a trawl last night at this station, and that was our first trawl here. And it was a very light catch. There's not a ton of biomass in it because we're in this part of the ocean that's very nutrient poor, it's ligotrophic, and so things tend to be less abundant. There was one really, really cool crustacean that was quite large, very beautiful, that we hadn't seen at other stations. I think the taxa that we're seeing are definitely tropical, more tropical, and different assemblages than we saw further south. So yeah, they are looking different. Some of the cyclothonia, I think, were much bigger than the ones we've been seeing further south. And I'm trying to think of other comments I've heard from the people who are sorting right now. The station?
It's right, but it's the same thing as one of those.
Okay. The station before this one further south had a lot of very large copepods. This one had fewer of those, and more other kinds of crustaceans. But in general, they're saying that the diversity in the assemblages that we're catching is much higher in this station and the one just south of us that we were at before. But the one at the very south, off of Puerto Madryn, was the least diverse in terms of the taxa that we were seeing, and it makes it really a hard job for them to to sort through the samples. It just takes a really long time when you have 10 different types of myctophys instead of 2, you know. You have to identify everyone and make sure it's the right one, do this careful microscope work. They're looking under the microscope for 12 hours pretty much nonstop, trying to, they're counting spines on their back, or I think that's a Keating there. So they have to spend a lot of time looking, I was just talking to someone about the copepods, and it's like, there's several different kinds of copepods. They have to be each identified under a microscope by looking at their characteristic features, and it's just really labor-intensive work. So they've been taking a long time to sort through the trawls at this station, at the last station, and this one relative to the first station, because of the diversity that they're seeing. But we've definitely moved into the tropical area with the more tropical species. We were seeing Antarctic species in our southern station, and those are gone, and now we're seeing this more tropical assemblages. So yeah, it's definitely changed a lot over the area that we've covered.
What's that?
Got the lock on.
No, did not.
But we trawled for longer, and we got less stuff, so that was kind of sad, because we were hoping that by trawling longer we'd get a nice, relatively large catch of things, but it's just very small. We're seeing a lot of hatchet fish around here. Actually, there were tons of those in this trawl. Maybe more than at southern stations. I don't want to say that before we've actually got any counts of things, but it did seem like there were a lot of them in the lab when I walked through.
No, that's interesting.
A lot of those specimens that are in the lab will be doing isotope analysis to look at food web, trophic levels. My lab is going to be doing metabolomics on the animals and some of their organs and their gut contents. We'll be sequencing genomes for the microbes in the gut of the animals. We'll be sequencing the genome of some of the animals. We've also collected water samples from the surrounding water to do metagenomic analysis of the microbes in those water masses, and we'll see whether the surrounding water has different microbes in it than the gut. And that'll help us understand whether the microbial activity that's happening inside the guts of the animals is distinct from what's happening outside of the animals. Our project is called Living Bioreactors, so we're interested in thinking about how the gut environment is promoting the cycling of carbon, or affecting the cycling of carbon and other nutrients. So there's people in the lab dissecting animals, taking the gut contents and keeping them so that we can do metagenomics and metabolomics on those samples. I think that makes it our job harder too when the diversity is more. We can't just say, give us the, copepods when there's 20 different kinds of copepods, and we say, oh, we want 3 of each one. Then we've got 100 samples of just copepods, and there's hundreds of other species and taxa to be concerned with. So we have to limit ourselves to the things that are most important. We have to make choices about which animals to actually study more. And when there's more different kinds, it makes it harder. Oh. Yeah, they're wondering about this yellow icon on that screen. That's the ROV. Oh, it's up there.
That's new over in
I hadn't seen it before either. It looks like it's your heading.
Yeah, it is.
Yeah. You sometimes show the acoustic data on that screen, right?
Sure. So what would you find more interesting? Population density of the same type of creature or a larger amount of diversity within
Like,
specific?
what
What would be more of a telling thing to you or something that would be more interesting to study? Like if you saw like a mass amount of like a certain type of creature where you saw a large, similar but different type, what would be what would you be like, okay, that's interesting, that's unexpected, I would like to know more about why this is this here as opposed to somewhere else?
Yeah, I mean, yeah. The animals are not my specialty. I think more about the phytoplankton, and I guess when you have a diverse population of phytoplankton, you might have a diverse population of things consuming those phytoplankton, and that might lead to more diverse communities. So oftentimes in the surface ocean, when it's some particular phytoplankton is blooming and they will take over the community and be the most abundant thing, then you might think the things consuming that would become relatively homogeneous as well, right? So this environment doesn't often have blooms happening that are substantial. They're more characterized by sort of a steady state of population of phytoplankton that perhaps that leads to more diverse community. I don't know, but if we were to find I think diversity is interesting because it suggests there's lots of different strategies for survival in that environment. And one of the things that one of the major questions in oceanography is we call it the paradox of the plankton. So, the water seems homogeneous. If you look at it, it's just water, but there's all these hundreds of different species living in it. So how does that happen? How do you get such diversity in such a apparently homogeneous environment? And I guess, it has to do with the different organisms having different strategies for living with different light levels, different pressure, different predators, different light conditions. All of those things will create different niches within the ocean so that it looks homogeneous because it's just water, but it's actually there's a lot of gradients in the water, in light and nutrients and those kinds of things. It can also be patchy. But these species of these animals they're looking at, they're so similar in appearance, but they might have totally different life strategies. Like they might eat different food. Some might migrate, others might not migrate with diet on the daily cycle. So you might think it's easy to just clump them together in the genus level or the family level or something like that. But then if you actually look at the species level, you'll see that they're actually quite different, even though they look the same. So having that species information becomes really important, and that's why they're spending so much time identifying all the animals at the species level. And yeah. I think in this expedition, there's just, I don't think many people have gone out and done all these different measurements in one place at one time, where we're sampling the animals, the bigger animals, the smaller animals, and crustaceans, jellies, and fish, and also looking at the water, the plankton, the productivity in the area, and relating all those things to each other. And there haven't been very many comprehensive midwater trawls.
Here in this area, or
In the South Atlantic. I mean, I was hearing today that there has been some done in the 60s and 70s by Argentinians and Germans working in the area. But for the kind of trawling that we're doing, it's less common. Yeah. I think there's been enough trawling that I don't know that we'll discover a lot of new species, but we'll get a better handle on how many of them there are, and the food web, and how their guts are functioning to process organic carbon. Yes, I see someone's commenting about the layers of data. We have many, and it is complicated coordinating the sampling for all of those layers of data. We have we all have our own ways that we are used to collecting samples, and now we have to kind of collaborate and mix these methods together and come out with samples that are good for everybody. And it's been a challenge, but it's been a rewarding challenge, and I think it's worked out pretty well. There's a cool jellyfish.
Sorry, I slowed that down.
Right. Review that.
Sorry about that, Chris.
That's all right. It's just really close to me now. You above me. Whoa, arm out. Oh. Didn't know what was going on. But yeah, it's definitely good. It's huge.
All lights on.
Yep. Good. Make sure that looks good. Alright. Yeah, so it's a little better there.
Yeah, just a little bit.
I think we have 7 or 8 postdocs on this cruise, and 3 or 4 grad students, 1 undergraduate student. So they'll all be doing projects based on this cruise.
Good. Alright.
Didn't want you getting all that good footage.
What's
I think that's not close to the ISO, it's hard to change it.
It is, it's not have to depending on that kid. So makes sense. Can't make Alex's job too easy on him anyway, so.
Yeah, yes.
I can see why we get so many keating gnats in our nets. That looks like a copepod up to the right.
Look at it.
Sure, he's gonna swim away, but I mean, they're pretty skittish. But maybe, look at that. There we go, a little copepod. You can see its little swimmer legs. Wow. Cute. I guess that's a clear one, because it doesn't seem to have any color.
Alright.
That was pretty good. He hung around for a little while.
He's cool with it till he wasn't. We're just going up to about 1,000. We'll hang around there and look around a little bit more. Just looking for interesting things to view and collect if they want to.
What is that?
It's a thing.
What?
It's a thing.
It's a thing. It looks almost crustacean-like. Yeah. Look at that. I wonder what that orange part is. If that's its belly, or maybe it's a waxy deposit. Eggs? Oh, that could be eggs. Yeah. Wow.
Yeah, shrimp. Maybe.
You can almost see the individual
Yeah. Ooh, there you go.
eggs in it. Nice.
Alright. You have whoever coming in here. Head. Yep. Alright.
How's it going?
Okay.
It's coming up.
How's it moving?
Pretty much, yeah. Mm-hmm. Yep.
Welcome. We have a new crew of drivers, pilots. How long are your shifts? An hour? 2 hours. All right. Hopefully you'll bring us some luck. We'll see something really cool.
What exactly are we doing? Just
We're
moving forward?
We're kind of moving a little bit forward, and up to get ourselves maybe to 1,000 meters. Not so fast that we can't stop, but not so slowly that we'll never make it. A speed that's good for being able to sort of spot something and maybe not go by it before it swims away. But if you look at this acoustic data around 1,000 meters, the animal density gets a little higher, so we might be more likely to see things. Not necessarily, but not necessarily things we can, they're kind of charismatic, but. red thing that drifted by.
Right top.
No. It went away.
On this case, if you see something, can move the camera and the zoom, or you chase it with the ROV? Because on the transect we cannot move, but now we can move.
We can move, yeah.
Okay.
Yeah, we're just exploring now.
Okay. Just to confirm.
Yeah, we can move. I can, yes. And we might want to collect something. So we would.
I'm more worried about the zoom in, zoom out, chase the animal with the camera.
Yeah, yeah. Yeah, there's a question about how we're going to characterize the carbon that is being carried by the animals. And I think, yeah, we're trying to, assess the gut volume of some of the animals, like the most abundant animals, and how many bacteria or archaea are in their guts. So we would be looking at gut volume and density of microbes, and then thinking about their migration patterns and where they might be pooping, and then characterize that, and then think about that and how that relates to particles that are sinking as well, and how those animals are contributing to particle production and particle sinking. But yeah, we do want to try to sort of characterize how many fish there are, how big are their guts, how many microbes are in their guts of each of them, and then scale that up to the entire, ocean basin level. And we do have a modeler who's part of the project, and she is not on the cruise because she does mostly computer work. She's at University of Southern California. Her name is Naomi Levine, and she'll be doing a particle model with us, as well as models on the metabolism of the bacteria that are in the guts. In my group, we're also thinking about the organic carbon that's dissolved in the ocean. So as we're looking at this video, you can see a lot of things are kind of gelatinous or slimy or very delicate. They're not really particles, but a lot of the organic matter you just can't see at all. Actually, the vast majority of the organic matter in this water you can't see. It's just dissolved in the water. Kind of like sugar. If you put sugar into a cup of water, it disappears. So there's a lot of organic matter that is dissolved, and these animals are also contributing to that pool of carbon, and that pool of carbon contains, for some reason, it contains a lot of molecules that can't be used by the bacteria that are there, or for some reason are not used by the bacteria under the conditions of the deep sea. So it hangs around for thousands of years, and we're also interested in how the animals are contributing to that pool of carbon that's kind of, we call it the refractory dissolved organic carbon pool, because it's kind of unusable. It's like if you tried to eat cardboard, you wouldn't be very successful at that compared to a piece of fruit that you can digest very well and get a lot of energy out of. So we're kind of studying all these different pools of carbon that dissolve the particulate, what's in the animals, in their animal guts. And I think that's the novel part, that most people who study particulate organic matter are not so much thinking about the animals. They're thinking about the particles and how they're sinking, but they're not necessarily linking them directly to the animals. There are some people who do that, but they do it mostly for fecal pellets for certain types of animals, not as broad a suite of animals as we're going to be looking at. Oh, wow. And that's the jellyfish. Oh, wow. And the siphonophore. Wow.
It's not focused.
It's pretty close. It's cool the way the tentacles are like start to get really bright halfway through. Would either of you guys like some dark chocolate?
Oh, no, I'm good, thanks.
There are lots of people who speak Spanish and also Portuguese on the ship. We can try to get somebody who's available. One of my postdocs is from Argentina. She sometimes comes in and talks a little bit. She's in the lab right now working on collecting samples from the net trawl. We actually have a lot of Spanish speakers on the ship. They're very busy right now. Our team that runs the trawls is from Chile, Ruben Escribano, and 2 people are with him. They all speak Spanish. Diana Arcila is originally from Colombia. She works at Scripps Institute of Oceanography, and she's also in the lab sorting samples. But we do try to get somebody to come in for a little while to speak Spanish during these dives. In fact, I can put out a request. That's a salt. I've put out a announcement asking if anybody's free to come speak to people in Spanish. We'll see what happens. So yeah, we're at almost 1,000 meters, and that is where our acoustics makes us think there's more animals. And I think we have actually seen a few more animals here than we were seeing. So maybe we'll get lucky and see more, even more. Okay. Keep going up a little bit. I mean, you're slowly ascending, right?
Yeah. Spanish speaker.
Oh, yay! Thank you. Oh, this is someone who has been running our nets from Chile, Susana. You can introduce yourself.
Oh.
Sit down. Or you can use another microphone, either way. There are people just wanting to talk about the project, you know, the samples are collected, what we're doing.
Ok. Hola, mi nombre es Susana, soy mexicana, pero actualmente trabajo en Chile y en esta oportunidad estoy participando en colaboración con el Schmidt Ocean y todo el grupo del crucero Bioreactor. Estamos enfrente de Brasil, en el Océano Pacífico. Esa es la zona en la que actualmente estamos trabajando. Y estamos, en el Atlántico, un poco nerviosa, es la primera vez que interactúo aquí, pero empezamos la campaña en enero y zarpamos desde las costas de Argentina. Así que ha sido una travesía muy larga y actualmente ya estamos situados en el Atlántico, reafirmo, frente a Brasil. Esperamos ya estar en los últimos trabajos de muestreo y pronto llegar a puerto. El crucero se trata principalmente de observar cómo es la fauna y la diversidad en la parte, sobre todo la parte del océano profundo. Esto tiene mucho que ver porque es muy importante en el ciclo de carbono. Hay muchos especialistas que están identificando peces, medusas y otros organismos que a simple vista no nos imaginamos que existen en este lugar, y así también ver cuál es el impacto que tienen en este ciclo de carbono. Hay algunos que trabajan con contenido estomacal, con microbios aún más pequeños todavía. Y lo que nosotros podemos ver con estas imágenes es que efectivamente hay mucha diversidad en profundidades, y también todas estas partículas que se ven en suspensión, cómo eso ayuda a esta parte del secuestro de carbono.
You talk about your nets. They were asking a lot about how, what we're seeing in the lab, the nets, how we're sampling.
Claro, una forma de estudiar no solamente esta parte de las imágenes para saber lo que hay, es tener estrategias o herramientas que nos permitan muestrar. Una de ellas son las redes de apertura y cierre que nosotros conocemos, que es para poder obtener organismos hasta ciertas profundidades. Y justamente estas redes nos permiten llegar alrededor de los 1500 o hemos llegado hasta 1700 en ocasiones de profundidad, y esto nos permite tener una mayor cantidad de organismos que nosotros podemos después identificar en el laboratorio, que también se hace aquí a bordo. Existen diferentes grupos que trabajan frente al microscopio para identificar estas especies, y han descubierto muchos ejemplares demasiado hermosos para nosotros, claro, y muy, muy interesantes. También contamos con que se están utilizando trampas de sedimento. Nosotros podemos ver en las imágenes que exactamente estas partículas que parecen que están flotando, bueno, las trampas de sedimento cuando se dejan a la deriva, se sueltan y ellas pueden captar justamente esas partículas que nosotros vemos, se acentúan y como que se quedan ahí en frascos, podríamos decirlo así, y que se van a sedimentar en esa parte, y así nosotros podemos saber de dónde viene esa materia, qué tipo de particularidades tiene, y también nos ayudan los estudios. Aparte hay otro tipo de redes que son más superficiales para organismos más pequeños, como los organismos del zooplancton, que también son importantes para nuestra identificación, porque son uno de los principales eslabones entre la parte de las microalgas que hacen la fotosíntesis, y estos también ayudan o son alimentos para organismos más grandes como los peces, y así parte de esta trama trófica.
Slideshow of our lab samples.
Claro, esta parte que ven las imágenes que está encima, podemos ver algunos organismos que se han sacado de estas muestras de las redes que les mencionaba, y también la parte de que estos tienen adaptaciones que les permiten, por ejemplo, sobrevivir a estas profundidades. Vemos que hay diferente diversidad de organismos, diferentes formas, diferentes colores, desde peces, medusas, y hay algunos organismos que generan colonias y que estos también les permiten, es una forma de poder sobrevivir a estos cambios, porque estamos hablando de más de 1000 metros donde la presión aumenta, entonces esto también les genera adaptaciones para que puedan sobrevivir a bajas temperaturas, a alta presión y poco oxígeno también. Hay una pregunta en el chat que dice que si nuestros resultados, nuestra biomasa de lo que migra, eso es parte de lo que se transporta en el carbono al océano profundo, y la respuesta es que efectivamente nosotros tenemos dos tipos de transporte en el ciclo de carbono en el océano. Uno es el transporte pasivo, que por ejemplo son estas partículas que se ven en la pantalla, que de acuerdo a su tamaño, a su peso y a la forma de la partícula van a tener la velocidad que solitas van a bajar hacia el fondo. Dentro de ese proceso puede también ser la parte del que se degraden por las bacterias, y el otro tipo de transporte es el transporte activo, que es por las migraciones de los organismos, ya sea peces o decápodos, que serían parecidos a los camarones que nosotros conocemos comúnmente, y así están repartiendo el carbono a lo largo del océano. Claro que también no solamente migran, sino también se alimentan, también se reproducen, también hacen excretan, y eso también impacta a esta parte del ciclo. Ok, mucho gusto saludarlos. Espero que sigan viendo y aprecien estas imágenes muy valiosas para nosotros los científicos, pero también para que la gente sepa que hay una gran biodiversidad en el océano profundo.
Thank you, Susana. Great. Now she's off to the lab. I don't speak Spanish very well, but I understand. I mean, I speak some Spanish and I understand some Spanish. Sounded like she was talking about carbon sinking into the deep ocean and how she's identifying all of the animals in the lab. And she's the one that came with the team that brought the net. It's called a mock nest. It's a multiple opening and closing system for catching midwater animals. And they're from Concepcion in Chile. There were a few pictures that were shown a minute ago from the lab, and some of them were from the catch from the nets, and some were from sediment traps, which are sort of, it's like a tube that we put out in the ocean, and particles sink into it, and you can catch them, and then you can look at them in the microscope, or you can do chemical analyses. Oh wow, that guy swam away. One of the images was of the particles fluorescing, and they can see fluorescent particles in the microscope. I think you can go forward a little bit slowly as you're going up.
Yeah.
'Cause I think that probably helps us cover more water, perhaps. Just, very slowly forward. About like 0.1, there it is. It's probably pretty good. Is that a larvation? I think so. Susanna, who was just here, studies copepods, and that's one of the main things they're hoping to collect in the nets.
Essa aqui é a senadora que eu vejo aqui. Aquela dali é a Nitra, pesquisadora principal aqui da nossa da pesquisa. Aí a gente consegue ver várias coisas aqui. A gente chamou o Mike, que ele é um dos brasileiros aqui. Depois vai poder falar um pouco mais aqui. E tem o Carlos aqui também, que é um outro brasileiro.
Nós estamos com o R na área, então tá tendo transmissão ao vivo. Se alguém tiver interesse em entrar.
Dá um oi lá, pessoal.
Vamos participar.
E a gente está esperando só que o Mike.
Olá, tudo bem? Transmitindo direto do Falcor Show para todos. Sejam bem-vindos à nossa cabine de controle. Tudo bem, vocês? Aqui a nossa sala de comando, o Cloud está pilotando no momento. Esse é o controle dele. Na mão direita dele você vê o joystick que controla a direção do veículo. Agora você vê ele usando a mão esquerda para cima e para baixo, ele controla a profundidade, subida e descida do veículo. Logo à frente da mão dele ele tem o controle da câmera principal. Do lado direito ele tem o controle da câmera secundária. E embaixo, nesta área aqui de baixo, estão os comandos de outras funções do veículo. Aqui é o centro, está o controle do guincho, nossa comunicação com a ponte, com todo o navio. Aqui o controle do guincho, quanto de cabo temos fora. E do meu lado aqui eu tenho o controle dos dois braços de 7 funções que fazem coletas. Quando estamos no fundo, não é o caso. O controle da câmara de ciência. E temos as telas de navegações toda a nossa frente. E para os cientistas que estão em volta trabalhando nessa área. O Carlos aqui, o nosso outro brasileiro, que faz vocês verem estas imagens, ele que controla a mídia e faz com que tudo pareça tão bonito. Infelizmente o veículo está na água agora, vocês não vão poder ver ele, mas naquela tela você pode ver o sistema de lançamento do veículo, aquele cabo que desce e que conecta ao veículo, que é controlado aqui de cima. E aqui nessas telas vocês veem o que a gente vê durante o voo e o manuseio do veículo. Estas telas são as câmeras que estão instaladas adiante. Uma câmera de alta definição, essas de cima, e as outras para ver o portal do veículo, que é onde coletamos e trabalhamos. É aparentemente simples. Muito obrigado.
Uma coisa bem legal que eu acho que é uma dúvida que eu tive, que é como que eles conseguem fazer a coleta dos animais aqui no mar profundo. E eles têm essas espécies dessas caixinhas aqui, eu aqui na cadeira, dessas caixinhas, e aí quando eles encontram um animal que é de interesse, então, e uma vez que o Delano ele achou uma água-viva que ele achou muito interessante, ele quis coletar, eles chegam perto com essas caixas do animal e com uma precisão, né, eles conseguem ir lá, fecham a tampa aqui, e aí a gente consegue analisar o animal aqui no laboratório e eles trazem para cima. Agora o ROV está a 910 metros de profundidade, como vocês podem ver não dá para ver muito mais do que só os pellets e a neve marinha, que é como o pessoal chama aqui. E agora a gente vai sair aqui do RLD, né, só para que o pessoal tá trabalhando aqui pra gente não ser xingado.
Oh, they're saying you need to get closer to the microphone.
What?
You need to put your microphone closer.
You want to say hi, Anitra?
Oh, maybe that's they can hear you, but these can. I mean, I can say. I can speak Portuguese.
Ó, Renata aqui. Conheci a Anitra aqui. This is Renata from my lab. Do you want to say?
Hello.
Oh, sorry.
Is somebody gonna? Hi. How are you? Yes.
There she is.
Yeah, no, we're very happy to do that. Glad you could join us. Okay. Okay, thank you. Bye-bye.
Thank you, Anitra.
Yeah. Not sure who's in the audience. They're the people.
Essa aqui é a Anitra, ela é a pesquisadora. Ela é a pesquisadora principal do
Yes. The people speaking in the room are actually doing a ship-to-shore event, and so they are not speaking into the microphone that I'm speaking into. They're speaking into headsets as they walk around the ship. So a ship-to-shore is where you can get a tour of the ship with a scientist who's sailing with us, and they walk around with a camera and show you around the ship and talk to the crew and show you the labs and the back aft deck where we do operations. And so those people that were on the other side of that call were getting a tour, and so they came into our room to get a tour of the ROV room. So they were talking, but they were kind of doing a different activity. Yeah, the ship-to-shores are pretty fun. People really enjoy doing them on the ship, and I hope the audience also enjoys it just as much because the people are really enthusiastic about doing them. We often have the postdocs and graduate students doing them. That was an undergraduate from Brazil doing that ship-to-shore, and it's a lot of fun. When we were further south doing this, there were larvation houses everywhere.
Yeah.
And now we're seeing them, but not nearly as many. Okay, I would be curious what that is.
I think that's a fish.
You think it's a fish? Okay.
Yeah.
Well, it's going to swim away, but let's see how close we can get. Oh, there's something. There's three things. Yeah, we're right in the depth where the acoustics say there's a little bit more animals. So that was 3 in one shot. Still think it's a fish. Is it a hatchet fish? It might be. Yeah, it's a hatchet fish, I think. Wow, cool, fun. We've been getting a lot of those in the nets at this station, all different sizes. So there's some little baby ones and some bigger ones. They're so shiny that it's hard to take pictures of them on the ROV because the lights are just reflecting. Oh, so cute. That's really good focus. It's going away. Nice. Oh my God. It's fun to watch them swim around. Much more fun than seeing them in the lab. He's trying to get away. Those are some of the fish that we are dissecting in the lab, and we're trying to take their gut contents and study what microbes they're living in them. That's the best view of a hatchet fish we've had.
Yeah.
We've seen a few, but we haven't, gotten so up close and clear. Nice. I think the ones that we've been collecting are anywhere from 0.5 centimeter in length to maybe 2 or 3 centimeters in length. The hatchet fish.
But we move the vessel to this location, slope, not constantly moving forward.
Oh, go to that one. Yeah. Get some footage of that guy right there. we might want to capture that. I think that's a foraminifera. If you could zoom in really close, that would be good. And then maybe we could capture it. And yeah, they do that. We could still capture it, even though it's a little.
You want to capture it?
Yeah, let's try. It's kind of small, but it's Do you see where it is in this camera?
Yeah, look at that.
He's got his spines have gotten kind of
think page.
messed up, but that's okay.
And close number 3. You ready? To close? No, to close the
Oh, there he
yes,
is.
you have to
Okay,
close it.
he's going for number 3. I'm gonna have to. Did he go in there? Nope.
Not sure.
It's a little hard to see.
I think this is it here. What is it? This?
It might be that. Yeah. Yeah, that's it. Yeah, I can see in this camera.
You don't think I did valve? Yeah. So number 3 valve.
Go for the 3.
Yeah. When it goes in.
Some working on
Close totally fast, and you go straight to the right.
Oh wow, this camera really allows you to see it. Oh, there it goes. Okay, wow.
And you go straight to the right.
Try one and see. I can't remember which one. If it's right or left or close.
That is a foraminifera. It's a protist, a single-celled eukaryote, and it's has a shell of calcium carbonate. At least that's what we decided. We're pretty sure that's what it is. It's unusual. I don't know if it's unusual, but that particular one is not one of the ones I easily identified. I thought it might have been a radiolaria, but we decided it was a foraminifera. The spines are made of calcium carbonate, assuming it is a foraminifera. If it was a radiolaria, they would be made of silica or glass. Oh,
close.
There it is. Close it. Close.
Stop.
Oh, it's closed. I don't know if we got him or not. Should we try to see? We probably will see more as we go up because we were seeing a lot of them up higher when we were descending. Yeah, I don't know.
I came back and down, so I'm not sure.
Okay, well.
I don't see anything inside.
I don't
see
either.
anything?
No.
Yeah, you could open it back.
Yeah. We can keep going. I think we will see more of those.
Get in.
The foraminifera skeleton is something that they're relatively large, kind of like a small grain of sand, and they tend to sink very fast because calcium carbonate is a pretty dense material relative to seawater. And there's another one.
That's the same one.
That was the same one. They tend to sink to the seafloor, and they record the chemistry of the water that they're in. So a lot of our records of the past ocean come from those skeletons, the chemistry of those skeletons, recovered from sediment cores.
Yeah, leave it like that. Leave it like no. But when we come around the top point, let me see the jaws. Yeah, like that. Just like that.
We actually have someone from another team within our group of collaborators that is interested in collecting foraminifera, and so they've been doing zooplankton net tows and collecting foraminifera from the water to do nitrogen isotopes and carbon isotopes measurements. And so they might be interested in this
This thing is so small.
individual. It's so small, I know, it is. It's like a grain of sand, maybe smaller. It's a single cell, but they have big spines. We don't have to keep going. Close the
Yeah,
jar.
close.
Close. Did we get him? Oh, we got
Yeah.
him.
Yeah.
No, that's not him. Oh, he's floating away now.
Now look him inside there.
Is he in there? Yeah, he's in there. You got him. All right.
Yeah,
Good job, guys.
number 3.
All right, we can keep going.
1-0. Set clock.
Good one,
Well done.
Rice girl.
If we go about 150 meters every hour, I think we'll be about right to get to the surface.
150 meters.
Right, every hour. We have till about. I mean, we want to have it on board by 8. So I don't know when you have to start doing the recovery. 7:30.
Yeah.
To be at the surface.
Yeah.
So
Let's start recovery like 30 minutes before.
yeah. So that means we have 5 hours.
We have a lot of time.
Yes, we have a lot of time. Don't go too fast. We can capture some more foraminifera. That was an okay biology sample. Foraminifera.
So have you guys got these in the shops as well? Or
What?
that what we just caught? Have you gotten any of those in the traps?
We have gotten forams in the traps, yes. I actually have the identification of that species. Yeah, we don't do it in. We don't get the forams in the fish nets. We get them in the zooplankton net because the mesh size is much smaller on the zooplankton net. So we're able to catch these small things with it. But you don't get that necessarily that many. So the name of that foraminifera is Hastagerinella digitata. That is the best I can do to pronounce it. All right.
Yeah, just move them slow, yeah. Concentrate. No, it's not moving. Right. Watch your snail trail. Snail trail, let's just adopt.
Yeah, it's just protein sufficiency.
So, I am constantly moving forward slow, so they could just move forward slow.
I guess it's like 2 or 3 meters up every minute, but we can also do it where we, stop for a while at a depth and then go faster. I think if we're moving forward at 0.1 or something, it's pretty good. Another siphonophore. Wow, look at that. Look at how delicate that tentacle is. It's just incredible. I see some cheers for the Brazilian scientists. They were the ones doing the ship to shore there, speaking in Portuguese.
Just going. And just move the station.
Bridge, ROV.
Alright.
Now you start to move slowly towards this direction, please.
Wow.
Can you move towards the speed about 0.2?
Which way do you want me to go? That's the station waypoint.
Yeah, to the station.
Copy, moving ahead.
Thank you.
It's like oh, there's another foram. Doliolid, okay. Oh wow, we really sped up, didn't we? We're going fast. That's okay. And you get to cover more water if you go a little faster, but maybe we should go 0.2 or something, I don't know. That was a shrimp, I think. I don't know, maybe 0.1 is better. What do you think? No. It's a larvation. Looks like he's home too. Oh, look what came out of it. Whoa. That's kind of interesting. There's another foraminifera. Oh, there's a nice one. Or maybe get some good footage of this one. Wow, that's a really nice one. Maybe collect that one.
You want this one?
Sure, yeah. We might, we can do the chemical analysis on a single foraminifera is enough to measure certain things. Like,
Do the focusing like.
oh wow, yeah. Now you can really tell it's a forum when you focus on that, because you can see that it's not a single sphere in the center. It's a bunch of bulbs. It's like that are kind of connected, almost like a bunch of grapes, and that's the shape, kind of classic shape of a lot of foraminifera. Whereas that's kind of one of the ways you can identify them. That was a pretty good shot. And then you can see that haze around the center of it that's also characteristic of the foraminifera. Oh yeah, wow. Okay, yep. They're so shiny.
Yeah, it's pretty zoomed in already, but you could try.
Oof. Wow. Yeah, so that the center is not fully, you can see it's not round. I mean, it's got the round sphere, and then inside of it, it's got the center. That's amazing. This is, someone's asking, what is it? It's a foraminifera. It's a single-celled protist that has these beautiful calcium carbonate shells. The center is I was saying, looks maybe a little bit like a bunch of grapes or a snail kind of, and then these spines are just very thin. And really, a lot of what we know about the past ocean comes from studying the chemistry of these spines in old ancient marine sediments. So paleoceanographers rely a lot on these. They measure the isotopic composition of the carbon and the oxygen and the nitrogen in the skeletons. The nitrogen comes from the proteins that the skeleton is laid down on, that the organism uses to make the skeleton. And then the calcium carbonate skeleton also has its own chemistry. It takes in ions like magnesium and strontium and all kinds of trace elements, and you can measure those in the shells. Yeah, those really are some amazing views of that foraminifera. Now we're going to capture it. Is that jar number 4 it's headed to? I closed. Oh, it went down. Suddenly it sat there, and then it suddenly dropped down. Did we get it? I don't know. It's kind of crazy that it was just sitting there, and then what caused it to suddenly get sucked down in there? All right, well, that's okay. No, I think there will be more.
Okay.
Oh, there he is. I think that the center is bright, maybe because it's calcium carbonate and it's reflecting the light differently. I don't think it's bioluminescent or anything like that. Oh, close. Close, close, close. No? No? It wasn't in there?
No.
Oh. I thought he was in there.
Is it there?
Is it?
Yes! He's gonna go into number 5. Now I think he's a little beat up. All right, let's move on. We can move on. We saw a ton of them coming down.
One more try.
Yeah, the spines are really big. I think it's big when you count as spines. It's like amazing how they make a single cell that much bigger by just growing those spines.
Yeah.
He's in there.
Inside.
I think he's in there.
Open again. That was inside.
All right, 4M. Is that stressful? And that's jelly jar 5?
That is
4. 4. We can keep going. That was really something. Are we looking for anything specific? Well, we started this dive with a quantitative survey, so we just flew through the water at different intervals for 15 minutes each, and then we're gonna look back at that footage and characterize the abundance of animals. And now we're just on the way up, and we're kind of a little bit having fun and a little bit collecting samples. We're looking for any animal that has a digestive tract that we can collect, but also because some of these protists, these single-celled organisms, are kind of interesting, we're also spending some time collecting those. If we found something more interesting, we would maybe let the foraminifera go, but we're collecting that because we have someone on the ship who's studying foraminifera and might like to have that sample.
Claude, let me know when I'm good to zoom in.
Yeah, you could zoom.
Wow, that is glowing.
These guys are awesome.
Oh, no, we've...
It's a galaxy.
You're good, good job.
I'll let you do
I think the beach you can't trust at all because
very
it's just gonna be.
Alright.
Yeah, you could find out.
So we went down to 1,500 meters, and we've just, during the survey, at regular intervals, we spent 15 minutes at each interval, and now we're just kind of going up and exploring what we see on the way up, collecting a few things. In some of our dives, we've collected water to filter and collect the particulate organic matter and dissolved organic matter, but we're not going to do that on this dive. Wow. Huh. What is going on with the EKE? Wow. Wow, look at that.
Orange dragon.
Wow. Huh.
Try to bring it back in the center.
Okay.
I think it's coming out of the lights.
Oh yeah, good point.
Wow.
This is a beautiful one. Wow. Let me know when I'm
Yeah, you
to,
can.
Oh, no. I feel like siphonophores are the most abundant things we see with the ROV in the midwater. So many different kinds.
That's good.
Nice focus. Wow. I'm not too knowledgeable about siphonophores. We have other people on the ship who are more able to speak to their life history and what they do.
That's a good.
Cool. Moving around in that.
Is it Sophia,
Yeah.
do you know if the siphonophores are related to the Portuguese man o' war?
Yes, they are.
Okay, yeah, so.
They're both hydrozoans.
Right, okay, so the siphonophore is related to the Portuguese man o' war, which once I was stung by, and it almost took me out. I was pretty allergic to it. I would probably not be a good idea for me to handle the siphonophores if I brought one up. See, I think that's just a particle. It's so bright. Yeah, just a particle. There you can see that particle disaggregate. That's the process that many people study for their entire life. It's true. Yes, I had the Portuguese man o' war stung almost my entire body, and that was nearly it for me. I was in Belize, snorkeling off of Belize. One of those, oh, maybe we should zoom in on that, yeah. I wonder if that's a, I don't know what it is.
I believe the Portuguese man o' war is this type of siphonophore.
Yeah.
It's just a super adapted one for the surface.
Uh-huh.
It's got the air fills in it.
Right. It makes me like the siphonophores less to know that, because
Sorry.
they're very beautiful. and dangerous. Apparently there's 175 species of siphonophore. I just read that. $800. It looks like a fish. Little fish, maybe. We've been catching little tiny fish in the nets that are almost translucent. That could be some of them. I think those look like a whole bunch of swarms of crustaceans there. Can you zoom in on that? Maybe not. Yeah. I thought I saw it. Yeah, I thought I saw spines, but maybe not. Never mind. I don't know. Yeah. It's okay. Ooh, what is that? Wow, there's just so many animals swimming around. We're at 870, 780. Wow. Keatingnath, or yeah, Keatingnath. Another Keatingnath. I think that's a Keatingnath. Never mind. Might be a fish. Huh? I think he's gonna run away. Yep, there he comes. Oh, a copepod. Oh, that's a nice copepod. Is it? I think it is. Wow, it's just floating around. It's like it's asleep or dead. Can you follow that guy? Is he alive? Yes, he is. Wow, he was just really relaxing.
Street, I was more. We were catching out stuff we end up because the characters come this way. Yeah, anything.
Let's see what that is.
Bridge, ROV.
It's okay.
I'm moving this station a little bit further out, please.
Yeah, moving northeast to the station. Point 2, yeah?
Point 2, thank you.
That's a little hatchet fish. 2 of them, maybe. think.
What's that?
Nothing. Never mind. Almost looks like the animals are starting to come up to the surface. On the acoustics, they're just ever so slightly coming up. Watch the sunset from here. Look at the camera. Oh, what's that? depths where organisms with a digestive system are usually found. I mean, I think they're probably at any depth. We can see that from the acoustics where some things are most abundant. Those things we see in the acoustics might have air bladders. Those might be things like fish with air bladders. They would have good digestive systems. The jellyfish also have digestive systems. Yeah, you can see the acoustic layers. It's a little messy looking right now. Acoustics works a little better when you're moving, and we're not really moving, so it looks a little bit not so great. But those horizontal lines are, over time, you can see that they're distinct depths, and on the x-axis you have time. So you can see that they're sort of at a constant depth over the course of the day, and now they're actually starting to very little bit, maybe inch up in the water column to do their nighttime ascent. Just one of the things that we're studying is this diel migration of animals. But all of these things we see swimming around, all the crustaceans have digestive tracts. We can't catch those so easily in the ROV containers, so we're not really targeting them. The jellyfish are fairly easy to catch, but sometimes they have digestive systems that are a little bit harder to, you don't see a lot of contents within them. Sometimes they're just a cavity and things do go in, but it's a simpler system. And then the fish are hard to catch with the ROV. I think we were hoping to maybe catch some kinds of jellies. We could possibly catch a cephalopod. We kind of did the other day. We've been kind of hanging out in this layer where the acoustics shows a lot of animals. Maybe we'll keep moving up though. Very slowly moving up. If we start to see a lot more animals, we'll probably hover at that depth for a little while and just fly through the water and see if we find more things. Yeah, go to check them out. Moving pretty fast.
move the cursor more east to northeast.
Okay.
What are you, general view?
Guys,
I just moved the day station again, a little bit further northeast.
got me moving on.
Thank you.
There's something there, huh? That looks like it's glowing. What is that? Wow, look at that up close. Well, maybe that's a well, maybe it's some kind of siphonophore, I don't know. Wow. What?
Zoom in.
Yeah.
Wow. Oh my God. That must have been some kind of colonial or eggs or something, yeah. Wow. That was kind of amazing. Pyrosome, yeah, that's what I was, that was the word I was trying to come up with, was pyrosome. But that one really disintegrated. The ones we've been getting in the nets are much more solid than that. Could have been eggs. I see, that's it. More heating gnats. It's time for more chocolate. Anyone?
No. Thanks.
Is that a 4M there or no? Something else. That's one of those jellyfish that we saw in the stomach of that fish, I think. Yeah. Oh, there's a little jelly. That's the same kind as the other one. That was, oh yeah, it's so amazing the way it moves. Oh. Do you know what that was, Sophia? I mean, it was a little bit iridescent, so it was a little bit ctenophore-like, but I don't think it was. I mean, I don't think that's what it was. Shrimp. Same kind.
What's it?
Foraminifera.
Foraminifera?
Foraminifera. You can just call them forams. That's easier.
Yeah.
You come here?
No, I'm going there. Doug just reminded me, like 5 minutes ago, the outstanding part of the PMs. We had to look at the water, which is basically just as we're doing the bridge, just like observe everything's moving on the ships and then downstairs and everything.
Yeah.
Weird happening, weird sound.
Okay. It's just coming up slowly.
Okay.
I don't even have any trims up. I'm just leaving it there float up.
Are you moving the vessel or are you just staying still?
Yeah, because the current is going north.
Yeah.
So I'm kind of like drifting slow with it.
Okay.
So every so often I just move it.
Okay.
She wants very slow movement
Okay,
because
no problem. What doctor were you gonna kind of stay at or go to?
I mean, I haven't hovered for too long at any particular depth, but looking at that, I might say something between 400 and 500, so 5 to 400. We might linger a little bit. I think Colleen's gonna come in any minute now and take over for me, but,
We can look at what's
you know, we're sort of just very slowly,
Maybe-
we're just hoping to pass by some things as we move up very slowly.
Don't worry about like if there's something on top of the thing, but just those two.
We're not seeing too many things,
Sure, wanna go look at that?
but
Trying, buddy.
there's something. That's another siphonophore.
Doug, I'm going to adjust your lights, and I'm going to adjust your.
Whoa, look at that thing move.
My camera's way crooked. Yeah.
Yeah, that thing is moving. Whoa.
This is.
And, you know, if you see something that looks cool,
Okay.
you can stop anytime.
Yeah, that thing is going, Chris. Sorry. He made his way into the porch and it disappeared. That fish is way too fast.
We got a good look at a hatchet fish.
Well, look at a hatchet fish, you say.
Yeah, we got a really good look at one. It was
Did
pre-
you? Awesome.
Yeah.
That's cool.
It kind of stays still. I mean, it swam around a little bit, but not so fast. We didn't get a good look at it. That looks like the dinner plate.
It does.
I mean, I think if you go at point 2, it's too fast to really stop. If you go at point 1, you can kind of cover some territory and then.
I'll be back in just a minute.
Okay, it's exactly 4 o'clock. Wow, she's pretty punctual.
chocolate.
I have chocolate. You have milk chocolate though. I brought dark chocolate. There's something there. All right. It's been nice watching with all of you. Someone else is coming to take over for me. I'll let them introduce themselves. Oh, wow.
Okay, where are we at? 697. Nice.
So I don't know,
Nice steps.
like, we've just been very slowly ascending and going about 0.1 knots.
Mm-hmm.
And zooming in on things.
Mm-hmm.
That's
Trying to collect anything or?
So cool, it's flown. We collected 2 4-ams.
Cool.
Uh-huh.
They will be excited.
Yeah, yeah, and the animals are starting to move up. I think it's very messy because they're going so slowly, but you can see it looks like they are moving.
Okay.
It's amazing, sparkling.
Wow.
We haven't seen, it's a little slow in the Trophic Ocean, but it's not.
It's beautiful.
Yeah. So I wrote down,
Have you tried to collect any ctenophores?
no, do you want to?
I mean, it looks like they have a gut.
Yeah, it does.
Can you grab that?
Could try.
Yeah. I'm writing down, I'm logging them too on C-Log, the collections.
Oh, okay.
So jelly jar 3 and 4 have forams in them, and those were the depths they were collected.
Okay. Is that on here?
It's in there.
Well, it was
It's
on
in
my
there.
computer that I was logging. I
Too
could
late.
log this one if you want.
Too late.
Oh,
Still in there.
practice.
It's in there.
Oh.
Hold on.
Go. Go, 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 go. Go, 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 go.
That's all I had.
Oh.
There it is. I don't know if it's up or not.
You can look in the other camera. It's in there. It's in
There
there.
he is.
Is it?
Yep.
I think
Yeah.
so. He's not moving at all.
I
but
don't see it.
Maybe not. Oh, it's
No?
just.
Oh,
I
yeah,
thought
yeah. There's. It's in
I
there.
think it's in there.
Yeah, it's in
Yeah,
there.
it's in
Oh,
there.
cool.
The glittery at the bottom.
Yeah. Oh, nice. Okay.
Those are all the
I
Lakers.
am doing it right now.
So then did you log that? They're all logged.
No, where's C-Log on? It's I was doing it on here before.
Lee was doing it on their computer and I'm doing it on mine.
Okay, I think it's right here. I think I got it.
You caught it despite my issues.
Can I can't log into C-Log. Can you log into yours on C-Log?
That's a ctenophore. I'll just log this.
Okay.
What depth are we?
690.
692. I don't see ctenophore. Do I just log that as a jelly? Oh, there it is. Ctenophore. Okay. Yep.
What's
That
that?
was jelly jar 5.
It was.
Yeah, it was.
Okay, I logged it. So
Okay,
can
could
set
you
up the
log-
next one?
Can
I don't know if I can log you in. Oh, look at that
You
one. That's a new
can.
one.
Can you log in with your login?
I don't know. I don't know if I remember my login. I think I'm logged in as somebody else. Oh no, that's me.
This has
Okay.
enough.
I can try. I don't know what I made my login.
I'm
Yeah, 'cause
trying.
I can't log into mine.
Creeping up
Let
on
me
me.
see if I wrote it down on here. That's a new one. I haven't seen that jellyfish.
Ooh.
Oh yeah. Okay, I wrote down my. There, I have it. Okay.
Cool colors.
Yeah.
Oh wow. It's really coiled up antenna.
Ooh, could you zoom in on? Is there like all the colors kind of like hanging out the top? Wow.
Oh, that was cool.
Oh, thank you. Okay.
Alright, you're facing forward meters. 54 meters from the ship.
Yeah, you're gonna have to move them. I'm drifting with the current.
Okay. Oh, you're not drifting?
They are not. They're stationary.
Bridge ROV, could move that waypoint forward, please. Are you drifting or are you staying stationary?
I'm stationary at the moment since we arrived at the waypoint.
Okay, what we'll do is I'll have you head towards that waypoint just to get us safe from where we are, and then you can sort of drift, and I'll see if that works for us, so if we get a little separation from you.
Okay, okay.
Thank you.
See you later.
Hmm.
You are.
I know you're close enough where you get into the shadow of the tower. You did think about getting close to that thing.
What do you think that is? abandoned larvation house, or is it the net of like something? Wow.
It's very interesting.
Yeah.
It's
It doesn't, it looks, the shape doesn't quite look like a larvation. It's too ring-like, right? Yeah, it's beautiful. Also those, what was, something cool next to it as well. Oh, wow. Huh.
Trying to get him back outside the county. Pretty sure that's where he is.
going down below. There he is.
Is it?
Yeah. I was waiting for it to come out and I'm like, oh, there he is.
Would it be crazy to turn the ROV around and see if that thing is still there behind us that was next to the fish? Or it's probably washed away. I think it was like, they might have been some radiolarians. But I couldn't quite tell because they never got in focus.
There's no telling where that is right now.
Yeah, okay.
Whatever, dude.
me see what.